हेलो
हेलो हेलो
थोड़ा सा मेरे को ऐसा कहा गया इसको वाला मेरे को
प्रियांशु रवि गया था किसी को बुलाने आया?
हाँ सर आ रहे हैं
अब हो गया जी साहब। हाँ सर ठीक है रेडी है। इसका लिंक
इसका सर वही कल वाला ही लिंक
डायरेक्टली शेयर करो। इस पे होता है ना डायरेक्टली शेयर होगा
सर उसका नहीं है वही वेबएक्स वाला ही है
पहले जो था।
हाँ अब सर उसमें एक बार चेक करना
प्रियांशु में जाना जो साइड में रखे हैं उसके नीचे जस्टिंग क्रॉस पड़ा था वो लेते हैं अरे हमको तो सब चाहिए यार सब है क्या आपके पास अच्छा
तो सर भी चेक करना
साइड में है
साउंड फुल करो उसका वीडियो भी स्टार्ट ही है
लाइव चल रहा है तो मेरा फोन मिल रहा है
लाइव है आप वीडियो स्टॉप डिले
तो सर रोटेट हो रहा है
क्या उसे कैमरा में रोटेट होता है।
हाँ वही लाइव
अरे तो बंद कर ना वीडियो बंद कर डिले इसमें भी दिखा
कैमरा रोटेट है
हाँ वही इसमें इस तरफ में हो रहा है इस तरफ हम लोग के साथ
अरे थोड़ा सा टेबल पर कुछ दीजिए ना जल्दी से
लिफ्टिंग डिले है देखो 1% यहाँ पे इसमें दिखा रहा है वो
कपड़ा मंगा ये सर और उसी कपड़ा से ये सब थोड़ा पोस्ट दीजिए
जल्दी पूछिए
ये सब थोड़ा मंगवा
कपड़ा तो पहले झाड़ू में आ जाना
कर दिया थोड़ा जल्दी से पास हो गया
झाड़ू खुला नहीं है
तो झाड़ू कहाँ से
कपड़ा सही हो जाए कॉल में
ये पोस्ट दीजिए और नीचे जो टेस्ट पड़ा हुआ है वो सब पोस्ट दीजिए
अरे वो सब पोस्ट देना फिर झाड़ू मार देना
सब कपड़ा मंगवा रहे हैं सब
लिंक भेजो ना भाई कौन सी का है सर लिंक का वही पीडीएफ है
हां
वही पीडीएफ थोड़ा आगे
नीचे जो झाड़ू लिंक का हम है
ठीक है हम लोग भी खाना खिलाया ना
बात नहीं हम वहां का कपड़ा चाहिए ना पोस्ट देते हैं YouTube पे चेक कर लो लाइव में साउंड आ रहा है
इसको
आप ही कोई
डिले चल रहा है
ना
रुको उस टाइम को बोल उसका आवाज
भेजे ना नहीं आएगा डिले है ये भेजो ना ये वाला लिंक से ठीक है ना
इसका पीडीएफ वही पीडीएफ वाला
पीडीएफ से कॉपी करके भेज दो कॉपी पूरा नहीं हो रहा ठीक है
है ना ये लिखा हुआ
हाँ पेन ड्राइव में कॉपी नहीं हो रहा नहीं रिकॉर्डिंग स्टार्ट नहीं हो रहा
कौन सा कॉपी
कल वाला वीडियो
कॉपी करना है
नहीं हो रहा
मेरे को ठीक है
ये वाला है सर QIP वाला
हेलो
पूरा
अरे 3% कर दो
पूरा नहीं कॉपी हुआ कैमरे कैमरा से पता
कहां पे पूरा नहीं
बीच में ऊपर नहीं होगा देखो नहीं पूरा लिंक कंट्रोल में आता है इधर तो पूरा
सब कुछ डन
कैमरा
भेजे सर भेजे
जुड़े हो? हाँ जुड़े हो। आपको बुलाओ। हाँ जुड़े हुए हैं सर।
Good morning, all of you. A warm good morning to all of you for the second day of this particular conference, International Conference on Advanced Trends in Engineering and Emerging Technology. So on second day, the first lecture, for today's first lecture, I want to invite Professor Atul Kumar Sharma. He has done his PhD from IIT Roorkee, MTech from MNIT Allahabad, and BTech from Uttar Pradesh Technical University. Right now he is involved with several academic as well as research activities, like he's in the editorial board of several journals like International Journal of Applied Mechanics, Frontiers in Materials, and different more. He has undertaken several DST serve sponsored projects, and he is handling so many projects also. He is involved with some startup research grants from Science and Technology. He has taken some startup grants from Science and Research Board. He was inspired faculty. He got an Inspired Faculty Award from Department of Science and Technology, Government of India in 2019. He was there in Israel in 2019 from Technion Israel Institute of Technology. And he is reviewing so many, as a researcher, he is reviewing so many journal papers like Advanced Materials, Smart Materials and Structures, and many more. And he has given invited talks, not only in India, but abroad also. So many invited talks he has given. So now I will welcome Atul Kumar Sharma on the dais, please.
Okay, so good morning also, and thank you all the organizer for
That voice is not clear.
Can you hear me?
Yes sir. Yes.
Okay, so thank you. So now I'm sharing my screen for the presentation.
From video भी on करें.
Okay, is my screen visible?
Yes, sir.
Okay, so good morning once again. So I will be delivering the talk on the just a minute. So I will be delivering my talk on the modeling of soft dielectric elastomer, which belongs to the category of smart materials. So, the title of my talk will go like this. So I will be first of all introducing the water dielectric elastomer actuators, and the initially I will be talking about the analytical modeling framework for homogeneously deforming dielectric elastomer actuators, and then I will be talking about the need of a finite element method for inhomogeneously deforming dielectric elastomer actuators. In particular, I will be talking about the electromechanical instability, which is one of a failure mode of dielectric elastomers, and the other modeling frameworks considering the effect of material anisotropy, viscoelasticity, and at the end, one of the important application that I am currently exploring, that is a use of dielectric elastomer actuator as a tunable phononic band gap stability. So, so first of all, the introduction of dielectric elastomers. So dielectric elastomers are nothing but the you can say that a polymeric film which is sandwiched between the two compliant electrodes. Is my screen visible? That slide with the introduction.
Yes, sir.
Okay, so that is with the introduction of the dielectric elastomer, because in my screen it is not changing. So just a minute. So my slides are changing. Can someone confirm? Okay, now network. So I will switch off my. Then we will see. Okay, so dielectric elastomers are nothing but a polymeric film like this, which is sent. So here these are the two compliant electrodes, one on the top and another one on the bottom. And if we apply a potential through these electrodes, so there will be accumulation of a positive and negative charge on the both the sides of the uh, membrane or this area. And because of and due to this force effect, you can say that it will expand in the lateral directions. Lateral directions and the contraction in the. Here you can see GIF where I am getting a electric elastomer and I am applying potential difference through this direction. You can see that how it is available here. And we apply potential. Uh,
But your voice is not clear.
So can you hear me? Because there was some network issue, I think. Okay, I'm re-sharing my screen. So I was not, because I was speaking, and I came to know that so because I have also logged in from another screen, so I was not able to see. Just a minute, I'm re-sharing from now computer. So is my screen visible now? Can you see my screen?
Yes, sir.
So you can see my PPT, the presentation file. Hello. Hello.
Yes, sir. Your screen is now visible. Yes.
Okay. So I was talking about the different applications of dielectric elastomers. So one of the applications was in the soft robotics, and you can see that they can replace these hard machines, or you can say that robot with made up of rigid links with a soft links. For example, if you want to mimic the motion of the elephant trunk, then you will be requiring n number of rigid link to mimic this kind of a motion. But with the help of these dielectric elastomers, the single link can achieve this 360 degree of deformation. Another one is this lens. You can see here, for example, if we talk about a rigid lens, it will have a single focal length. But if you are using the soft material, you can obtain the variable focal length, okay, with the help of electrical actuation, or some other mode of actuations. And here you can see that this is an example which mimics the facial expression of a human. So now, if we talk about the challenges behind modeling of these dielectric elastomers, so one is that these materials have non-linear constitutive relations, and also we have, because we are talking about this deformation because of this electrical loading, so we will be having this electromechanical coupling. Other than this, they may undergo the some instabilities like a morphological instability like wrinkling or the breakdown because of the or dielectric breakdown. Okay. And another advantage is that they require the high voltage, okay, for operation. So in order to effective and reliable design of dielectric elastomer based design, you need an efficient and computational model which can capture all these phenomena. So in this regard, so I will be first of all talking about the modeling of the dielectric elastomer with a simple planar configuration, and then here we will be making some assumptions like so for example, you have this dielectric elastomeric film of a dimension 2L, 2L and 2H, and when it is subjected to the combined electromechanical loadings, like here we have a loading mechanical loading, so I'm pulling it in the planar direction as well as I'm applying the potential difference. So here you will see that you can see that expansion of this membrane or this dielectric elastomer membrane, and here this equation shows the deformation configure profile, like how this or you can say that it defines the kinematics or relates the coordinate of a particle here in the undeformed configuration to the deformed configuration. And in order to model these dielectric elastomers, I will be utilizing this Newtonian model, which defines the strain energy per unit deformed volume of the elastomer and the work done by the mechanical forces. So that is nothing but the work done by these P1 and P2 forces in the lateral direction. And this is the work done because of this electrostatic force. As I said in the first slide, that when we apply a potential difference, there will be accumulation of positive and negative charge on both the surfaces, and because of those, there will be an attractive force. Okay, and the work done by that attractive force will be like this. And then once we have the expression for the strain energy density and the work done or work potential, we will be now calculating the total potential energy of the system, which is nothing but the sum of the strain energy or the elastic energy of the system or energy stored in the system and the work done by the external forces. Here we have two type of forces, mechanical and the electrical forces. And once you have the total potential of energy, so you can apply the principle of a minimization of potential energy in order to derive the equations governing the electromechanically induced deformation of this membrane. So here are the two equations. You know that for maximization and minimization, the necessary condition is that the first derivative of that function should be 0. So here we have two variables, lambda 1 and lambda 2. So we are taking the first derivative of u with respect to lambda 1 and lambda 2 equal to 0, and we will obtain two nonlinear algebraic equations, which will define the relationship between the input, which may be the mechanical force and the electrical force, and the output will be the lambda 1 lambda 2, which defines the deformations. Okay, so you can see that how it is defining the deformation. These are the stretch ratios. So initial dimension is 2L and later it is becoming 2L lambda 1. So and after that once you have the equation of motion, you can plot the relationship, or you can plot the voltage versus stretch or the deformation profile by using these two equations. Like for a mechanical system, like for axial bar, you have a force displacement relationship. Similarly, here we have a voltage displacement relationship or the voltage stretch ratio deformation. And other than this, but here the system may be, because if you know that these are the primary conditions on the maximization or minimization, but to check whether this deformation is corresponding to the maximization or minimization, you need the second derivative of the function. So here, if your total potential energy is corresponding to the maximization, then the second derivative should be negative, or you can say that Hessian matrix should, determinant of Hessian matrix should be negative. If it is corresponding to the minimization, it should be positive. But there will be, if you are moving from stable equilibrium to unstable equilibrium, there will be a critical point where this, because you are moving from positive to negative, so there will be a critical point where the second derivative will be 0, or the determinant of this Hessian matrix is 0. So that defines the critical point. Okay, and we can extract these critical value of that applied magnet voltage and the corresponding deformation by solving these three equations. And we performed a parametric study where we find out how this mechanical loading is affecting the requirement or the voltage at the failure point. Okay, so here we find out that pre-stress play a favorable role as it enhances the travel range of the stable operation. Means the deformation achieved with the pre-mechanical loading is more than the deformation without pre-mechanical loading. Okay, so this is the one point. But this model, which seems to be very simple, is valid for planar deformation only. So where the deformations are very small. Deformations are restricted to this homogeneous deformation, means planar deformation. But this was the idealization case. But if we talk about the actual or practical application, like a gripping of some object, here you will see that this material is undergoing inhomogeneous deformation. Deformation is not same at each and every point like in the first case. Another example is this is an example of a lens. So the deformation at this point may be different than this point. So in order to solve such problems, we need the solution of a boundary value problem. And which one of the method to solve the boundary value problem is the finite element method. So with the help of this, we can capture the inhomogeneous deformation. Another thing is that localized this breakdown as well as this wrinkling you see in the second GIF. Okay, so the next work that we did is related to the finite element modeling to capture these phenomena in dielectric elastomer based devices. So here these are the mathematical equations, or you can say that these equations defines the kinematics, and these are the constitutive law, and these are the governing equations. One pertaining to the mechanical domain, which is the stress equilibrium equations, and these are pertaining to the electrical domain. And by utilizing this virtual work statement or the variational form, we or you can say that these are the weak form pertaining to these strong forms, okay, that we obtain using the utilizing the virtual work statement. And then in finite element method, so we these are the approximation for the displacement and voltage within a particular finite element, and after inserting these expressions in the you can say that a variational statement, we come up with this residual elemental level equations, which pertains to the mechanical domain as well as the electrical domain. And these are highly nonlinear in nature because of the material nonlinearity as well as the geometric nonlinearity. So in order to solve these two equations, we utilize the staggered formulation and along with the Newton-Raphson method. Okay, so or we solve it in incremental way. We have some initial guess for the displacement and the phi vector or the voltage, and then we are optimized or we are getting using Newton-Raphson method. We are getting the converse solution for each loading of a voltage. And another so as I said that we utilized in a new the two material model. One is the Newhoeken material model, and another one is the Ghent model, which capture the strain stiffening effect. And as we know that this rubber is incompressible in nature. Okay, so means the volume, because of this volume conservation, in the finite element model, we encounter a numerical instability called volumetric locking. In order to alleviate this volumetric locking, so we utilized this J-bar method. Okay, so we were the first to implement this method in the dielectric elastomer domain, and so other methods as well, like a Hughes formulation, as well as the or UPZ formulation we called, as well as this F-bar method, and other method is related to this reduced integration in order to alleviate this volumetric locking phenomenon. But he utilized this J-bar method, which was more efficient than the other method. That I will show the efficacy of this method in comparison to the other method in terms of time. And by using the finite element the method, we captured this the location of the failure point, and we observed that always this failure will be occurring near to the boundary. Means this is the active region and this is the inactive region. So always we find out that that the breakdown will occur at near to the boundary, because the deformation are larger than at the boundary in comparison through the other domain. So this is the point of a maximum deformation, and that leads to the dielectric breakdown. And we performed also a parametric study how the pre-stretch or initial pre-stretch affect this point, and also the area or that ratio between this active to inactive area. So we performed a parametric study, and we find out that these points, we can say that the voltage at the failure point is dependent on these parameters as well. And then we validated our model with the for a simple case using analytical method. And later we considered the viscoelastic effect, because these materials have time dependent material properties, and then we simulated certain cases. So I'm not going ahead behind the formulation, just some example that we solved. One of the example, this was a bilayer bending actuator. Here we have two layers, like one is made up of this electroactive polymer, another is just a simple rubber, you can say. And we are applying the potential difference into the one layer only, and because as we know that because of the if we apply a potential difference through one layer, then there will be a expansion of the first layer, and because of this combined effect of both the layers, we will have a bending kind of a deformation. So here we can see that bending deformation of a dielectric elastomer actuator. And with the help of this, we also created a 4-finger gripper. You can see here. So we have attached 4 bilayered actuator, you can say that arms, to a rigid block in between, and then we can obtain this we can create this 4-finger grip, and then we can achieve this kind of a motion as well. Another example that we solved was related to this buckling pump. So here we have two separated, you can say that, dielectric films, and with it is restricted at both the ends. And then if we apply a potential difference, we can achieve this kind of a buckling phenomena as well. Okay, like we have, for example, if we have a fix, you can say that column, and then if we apply this axial force, and you can achieve such kind of a buckling patterns. Same thing is happening here, but this phenomena is induced by the electrical loading, not because of the mechanical loading. So another thing is that we consider this material anisotropy as well. So this helps us to enhance the travel rate. Earlier we said that the failure is so we have seen this critical point value. Okay, so where we put the second derivative of that energy, that potential energy to be zero, and we obtain the critical value of the applied voltage and the corresponding deformation. Here we find out that if we have this fiber reinforced dielectric elastomer actuators, this travel range has enhanced because of the material anisotropy. Okay, this was another study we performed related to the anisotropic effects on the electromechanical actuation performance of a dielectric class. So here you can see that we uh, simulated these three configurations: one pertaining to this bending actuation, another one pertaining to this buckling actuator. And as I said that in particular towards the development or the developments towards enhancing the computational capabilities, we utilize this staggered formulation over monolithic formulation where we are solving. So in particular in staggered, and the basic difference is that I'm solving this mechanical domain equation and the electrical domain equation separately, one by one. But in monolithic approach, we are solving at a time. And one thing that we observed was that this the time taken in the by the staggered approach at a larger density is lesser than the monolithic mesh density is lesser than the monolithic approach. So our staggered formulation is much more computationally efficient than the monolithic formulation in terms of a time taken to solve the same problem. Another thing that we enhanced was the use of a J-bar method and its efficacy over the J-bar method in combination of a staggered approach. So again, this method was more efficient than the F-bar method and the multi-field formulation, which is also UPJ formulation. So here we can see the how much it is efficient. It's not allowed above certain frequency range. Let's say this is the range. Let's say 60 to 80. But if we made these periodic structure with the let's say soft material like dielectric elastomers, by application of this the applied electric voltage, we can tune the band gap properties. So here you can say that tuning. So here you can say that earlier with the same structure we were having band gap in the range let's say 3.5 to 4.5, but here it has changed. Okay, so this we can see the tuning of the band gap uh, with the help of a single structure. Okay, so then later we perform some like a topology optimization framework to find out. So here this is a standard shape of a inclusion, but if we are using this kind of a structure or this composite structure, we will have a wider band gap. So you can see that band gap is much more larger here. It may be in the frequency range from 5 kilohertz to around 9 kilohertz. Okay, so these are the potential applications uh, that we are exploring here at IIT Jodhpur. So that earlier work was pertaining to my postdoctoral work and the PhD work, but this is the one of the applications we are exploring here at IIT Jodhpur. Okay, so with this I will close here. So thank you. If you have any question, you may ask me. So I'm done. Professor Sahu.
Thank you, Atulji. Any questions from the audience? Yeah.
Okay, Dr. Atul, it was a nice presentation, and I have a questions related to, can you hear me?
Yes, I can hear you.
Yeah, I have a questions related to what are the limitations or which you face in this modeling?
Okay, so one of the part is that in terms of finite element modeling, we have to capture this nonlinear material behavior. Okay, so and also you can say that that was one of the part behind the modeling. Another one was the related to this volumetric locking, which is very challenging when we talk about the material incompressibility. Okay, there are lots of methods available, but we can utilize this reduced integration method. But the problem is that how much so thing is that if we talk about the application side, then one is that the requirement of high voltage, and we utilize the or then we in order to reduce that requirement of a voltage, then we talked about this material anisotropy. So that can enhance the requirement on the requirement on the voltage side.
Okay, okay, thank you,
Yeah,
sir.
so these were the two, you can say, major things. Yeah. So is there any other question? Okay.
I think there is
So
no question from audience side. Thank you, sir, for your valuable input to this conference. Thank you so much. Moving to next,
thank you. Thanks a lot. Yeah.
we have a well-known researcher from different area of mechanical engineering. Today we have as a invited guest speaker. I welcome sir, 2 minutes. Sir, have a seat on the dais, please. Now I would like to invite Dasankar sir, our Dean of Academics, to felicitate with a shawl and bouquet to Karali Patra sir. Patra sir, have a seat on the dais, please. Now I would like to invite Dr. Sambhu Kumar to felicitate with the bouquet and shawl to Rakesh sir, Associate Professor, Department of Mechanical Engineering, IIT ISM Dhanbad. Sir, have a seat on the dais, please. Now I would like to invite Dr. Anushka Pradhan to felicitate with a shawl and memento to Dr. Piyush Kumar, Associate Professor in the Department of Aerospace and Mechanical Engineering, University of Texas. Piyush sir, kindly have a seat on the dais, please. First of all, I would like to say sorry to Kalyan sir. We are actually 10 minutes late. It was scheduled from 10:30, your speech. We have our next invited speaker, Dr. Kalyan Kumar Singh sir. He is working as Associate Professor in the Department of Mechanical Engineering at IIT ISM Dhanbad.
He was the Dean of Administration and Associate Dean Mentoring and Review at IIT ISM Dhanbad. He joined ISM Dhanbad in August 2019, in August 2009. He is among the top 2% globally according to the survey conducted by the Stanford University from 2022 to 2025 in consecutive years. Dr. Singh is selected for State Coordinator for the State of Jharkhand by MHRD, New Delhi, for a state-specific perspective plan for technical education in India. Sir is founder chairman of Indian Society for Advancement of Material and Process Engineering, ISAM PE, Dhanbad chapter. He was the honorary secretary from 2016 to 2018 of the Indian Institution of Engineers, India, Dhanbad local chapter. Sir has done his BTech from Bangalore University, MTech from VTU University, and PhD from Dr. APJ Abdul Kalam Technical University, Lucknow. And Sir was working on his PhD project in IIT Kanpur. Sir has published 3 books and more than 200 reputed research journals in international Asia journals only. The total value of his R&D projects and STTP courses were more than 2 crores. He is the life member of IST. Apart from all these, through the extremely academic knowledge, he has taken interest in teaching students of UG and PG level in different courses. Sir has guided more than 20 PhD scholars and more than 55 MTech projects in his academic career. Sir is dealing with many consultancy projects for the government and for different organizations like DRDO and other. Sir, the stage is yours. You can now start with your presentation. Thank you.
Hello. So good morning to all of you. Thanks for nice introduction for me. And I should say this morning, so a special thanks to Sambhu Kumar. He is a contact point between me and for this today where I am. He only contacted me and then finally I agreed and I came here. So today the Honorable Principal of this institute, Vice Principal, Dean, other faculty members who is associated with this conference, distinguished speaker today, my friends Karali Patra, which are very long friends, I can say more than 20 years, and my others, Rakesh ji is here, and Piyush ji is here, Rajkumar ji is here, and all the peoples who are attending today this my talk. I'm going to tell you about this innovation, what we have started from zero to till today, starting from first paper to reaching to the 211 papers, starting from the zero funding, around 2.5 CR fundings. Now our students is faculty in IIT Madras and other NITs. So that I will start. Those who are not from the composite also, they can understand that talk. So I will start in that fashion and will reach up to the highest level what we are doing today in the international scenario. So the topic of this, the impact behavior of the carbon nanotubes induced advanced FRP composites. See, the composite basically the 3 types: PMC, MMC, and CMC, polymer matrix, metal matrix, and ceramic matrix. So here today I will talk about the FRP composite, fiber reinforced polymer composites. And especially in the fiber reinforced impact composites, we will talk about the impact damage analysis. This is the one of the area of my research. One group of students is working in this area. So I want to tell you this today, because if you see about the impacted, people will tell about this is impacted and this is going to the field. If you see the fundamental of this impact, हम लोग मैकेनिकल वाले हैं, जब तक टूटता नहीं है छोड़ते नहीं है ना. So we'll see about how the impact is working. When it is impacted, the physically it is stress is going to the impact on that. When there is a stress, strain is coming in the picture. When there is a strain hardening will come. When strain hardening will come, crack initiation will take place. When crack initiation takes place, crack propagation will take place. When crack propagation takes place, material is going to. That is the history behind that, how the impact is going to work inside to the material. Normally we can say simple by the austenite, bainite, cementite and the VCC, FCC and SCP. You can correlate it and you can give the information about that. Here is no question of VCC, FCC and SCP. No austenite, bainite and cementite. We are talking for the material stress is going to transfer from the one layer to the other layers and how we can damage it, how we can protect it. Suppose the flight is going to damage, simply we cannot say we have to throw it. We have to get repair of those type of the places that it is going to the damaged by the bird hit or by the some other means. Okay, please go to the next slides. So here, if you see about, I will not read line by line, then it may not be interesting because we understand. So I will tell you in the language. If you see about this, the fibers reinforced, we can say one is the fibers, other one the matrices. If you take about the simple your hands, if you see these hands, the outside is the muscles and inside it is bone. We can say this bone is nothing but for me, it is the fibers and outside is nothing but the matrices. If you see open a book, the good authors, Alan Klein, you can say about what is this composites then. The composites, if you see the broad definition of the composites, the load is taken by the matrices and it will transfer to the fibers and finally fiber is supporting them. If you see about your hands, if you see the beams and all this, you can find out how the load is directly. You can say the iron is taking the load, but the cement, the concrete is all there to support them. So if you see about, this is the fundamentals, the definition of that. Go to the next. This is the matrix, the reinforcements, the composites, what I had told you. Just I have taken the example of my hands, or you can take example of the beams. Next. Now the question is then, why composites? The question is why composites? Because it is a lightweight materials, high strength to weight ratio, aspect ratio is very good, and wide application at advanced materials like industries, aerospace, aircraft, and marines, automobiles. And we have the lot of design flexibility. We have design flexibility. Next. And you have the extended life, the low maintenance. These are the things we are working towards the composites. Next. See, this picture will come in front of you when something is going to the impacted one. This is the car. This is my campus, IIT campus, one of the professor cars. Here you can see we can change it easily by changing the materials and it will become the new. No one can find out here it was impacted there. So if you see about the whole this impact examples here, everything is repairable. If you find out especially the flight, the Taneja aerospace industries, I had worked for few months for that industries. That is a maintenance doing the aerospace industries in India. If you find out that some of the big person have his own flight, where they will go for the repair, they have to go to the Taneja aerospace industries and they have to get the repairs. So this what they are doing, what is the role of engineers there? They have to again check the product and replace it, and we have to do the different types of the repairing process also for doing those types of the products. So these are the things where we can overcome by repairing and all this. Go to the next. Then I'm coming to the code, and here we'll talk about how this is the composite and impact is associated. What I told you just now, if you talk about this bainite, cementite and austenite with the BCC, FCC and SCP, if you find some correlation, you will get some of the answer from there. Yeah, it is correlated with that. This is the SCP, this property is along with the SCP. Here, my friends, this is not here. We are talking for the FRBs. Here we have to say about how much fiber strength is there and how it is correlated. Before 2008, if you see this publication, once it is impacted, it is very difficult how the inner layer of the surface is impacted. 2008, we published a paper in that, impact layers of that. And honestly, information I want to share with you. Bell Helicopter Company USA, they all are using that papers, how to find out the materials, it is a great impact. This is our work from our lab only, from IIT Kanpur lab. So if you see about those type of the impact is coming in the pictures, we started from the base materials and going up to that much level. Next. So that literature survey, you can skip it. आगे बढ़ जाइए. Now if you see about this things, the impact is before my research journey start from 2002. So if you see that before that also people was working, and what we have. So if you see that before that also people was working, and what we have addition in this research area in that. So till 4 component is there. You have to select the 4 component is there. You have to select the problems, go for the mathematics, go some experimentation, do some softwares, nowadays AIML, and go some metallurgical microscopic examination. Then the research cycle will complete. Otherwise, if you leave some cycle, there is a scope, something is going wrong. If you complete all this cycle, so this is the mathematical background of that. We found out here the Bij equal to 0. What is meaning of that Bij equal to 0? If I want to say that, if any matrix, if the total stress is going to transfer, it is directly going to the next step. The fundamentals, I hope that everybody is knowing about here, is when the students also. If you see about the iron carbon, this mild steel cases, you have this, then that means from here to here Hooke's law, here lower yield point, upper yield point, ultimate point, fracture point. If you see the cast iron, it will go and going to the fail. If you see the composites, it will go one layer, fail. Again, the number of layer is more, so many times that is going to take the load and again going to the fail it up. So this is the beauty of these composites. The whole, if you allow them to whole load is going to transfer to the next layers, what is happen? That surface is stress free. If that surface is stress free, there is no strain hardening, there is no material is going to the fail. The how much you can do this Bij 0, that is also a turning of your problem creation when you are creating the problems. Next. This is, if you find out in anywhere in this net, these papers, this is our direct input to the industry, this research industry. This we have given this thought, yeah, this is the angle, we can take it, and this angle, how much it is there. Behind this angle here, I just put the photograph. When you were working on composites, you can see this figure, you can identify this is the input from India. Okay, so go to the next. So, go to next. So here we have to solve it, and finally what I told you, that Bij equal to 0. So here we have to find out how much layer is there and how we can find out the minimize and go for this solving this mathematical equation and try to get it. Now if you see about you will get more than one students. One student will follow this model, other student you are changing the direction. Again you tell them to please solve and bring it here. If they are able to solve it, take them 15 days time. थोड़ा समय लगने दीजिए उसको. When he is able to solve it, you can understand what is happening with the materials when the material is under these conditions. Next. So now coming to the material preparations. So if you see about the material preparation, initially we don't have any course in IIT ISM Dhanbad 17 years back. We have developed the course composite material and developed the lab also, and see the journey how we have started from the earlier ones. So we have taken the materials and we have to prepare it by our hand lab techniques. And then after making, go to next slide. Next. Or बढ़िए. Go to back. Yes. Please. No. यहाँ पर रुक जाइए. So here what will happen? We have to take in the materials and we have to put it in the hand lab techniques. And you look at this figure in 2009. We don't have the pressing machine, and this we have made it by the, we can say that the Jugaad technology. When you do the research, it's what I have learned till today in so many years. Definitely we should follow some of the high grade professors or some of the very good industries. I am following Boeing here in my research. So Boeing, you know, Boeing is making the flight. So Boeing material thickness is 4.2 mm. So we are considering all the materials for 4.2 mm. and we are making this the technique, and we have prepared it. The pressing machine here, we have to apply the load here by the vacuum we create here and give the load here. The other pressing machine is there in the lab. It is designed by ourselves, and making the laminate. Nobody can ask where you have prepared it, because the quality was so good. We don't have this facility. Why you are looking today? That is very recently, 2 years back. Now I purchased this machine. This is in the working condition in my lab. And see here, this is the autoclave. This is the way using what you are doing, the DRDO and ISRO they are using. This is the autoclave. So fundamentally, if you see about the flat surface, we have to go for the pressing machine. But if you go for the curved surfaces, we have to go towards this type of the autoclave. Otherwise, it is very difficult to make the curved surface product. So starting from the zero, we reach up to the highest level, and this autoclave, what the best researcher is using nowadays, that is available in the labs. Next. Go to next. After that, we have to test it by this the facility we have, the universal testing machine by the hospital, and we have to do the testing of this product in the lab, but the different type of the testings operations. Go to next. Now look at it here. What we are talking it, when we have the neat GFRP, glass fiber reinforced polymers, and we have the 1%, we have to see the 2%, we see the 3% and 4%. You see here the displacement versus load diagram is this, how it is due to the MWCNT addition of that with the epoxies. When you are mixing with the epoxies with that, with the accelerator and hardeners, this will give some of the properties what you are getting in terms of the testing it here. Okay, so next. See here about this the ILSS test. Here when you're doing the ILSS test, the important point is here, when you apply the load here, what is different between the 3-point and ILSS? The ILSS specimen size is small. So here we have to be careful, when the material is loaded, material should take the load, machine should not take the load. Many of the times it's happening, the machine is start taking the load because this person is going to touch to the machine and researcher is feel happy, yeah, material is taking the load. Material is not taking the load that time, the machine is taking the load. So we have to be careful here, and we have to see about how we can do the ILSS. See here, the ILSS also we are getting the better result when I'm mixing this 3%, this MWCNT. Next, you can use my lab. You please visit us, 0.5 meter per second, this is the impact velocity. We have tested it, and what I have told you in the initial, in the different type of the variation, it's a 0.5 to up to the 4 weight percentage of that. 4 weight percentage of that. If you see about the different variation, low weight percentage of that. If you see about the different variation, lot of data is generated through this. Okay, so we try to show you what is important for the today, and you can make your interest for that. So again, you see about this the laminate, how it is going to prepare, and see the dimension, and it was impacted. Next, go to the next. See here in this, please go back. See here, if you see about all those types of the impact, it is carried out. Now I am telling you the overall about the gist of this today presentation. So the remaining slide, you feel happy to see that. If you see about the glass fiber and the carbon fibers, and there we have to apply the multi-wall carbon nanotubes, and we have to see about how much it is impacted, how much load carrying capacity. If you see about 1 meter glass fiber, the cost is around 200 rupees. 1 meter glass fiber, the cost is around 200 rupees. 1 meter by 1 meter by 1 meter. And if you see the 1 meter by 1 meter carbon fiber, the cost is around 3,000 rupees. So by doing all these experiments, we find and come a conclusion in that, why not we can take the basalt fibers. The basalt fiber cost is around 1,500 rupees. GSM, that means we can say GSM is gram per square meters. If you see 1 meter by 1 meter, how much cost is there? And if you mix with the basalt fiber with the MWCNT, the strength is almost equal to the carbon fibers. And that area again, if you see the research review, it is a 0. Santosh have done the PhD in this area, and he published 12 Q1 Q2 paper. Now he is in IIT Allahabad.
Okay, so we have find out and we try to give those information in the lab scale level, what is happening internationally in this field. So here if you see about glass fiber, carbon fibers, and you find out the carbon fiber, we know that carbon fiber is a better materials. If you see two cars, if you target is you want to buy a car, see all the car is running on the road. All the car have to take one place to the other place. Some cost is 50 lakhs, 1 crores. If you take a material scientist, what is happening there? The design is different. The material, nobody want to die. Everybody want to save his life. So the impact strength of that material, the carbon fiber, it is very high. So if you see about starting from the first Indian car by Sachin Tendulkar, that Ferrari, starting from there, if you see about, it's a carbon fiber is using most of them costliest car because they have the very good impact carrying capacity. If I can say this information to the industry, that why you are going for the carbon fiber, go for the basalt fiber, use with the MWCNT, they will definitely give you the money. Because vitamin M is necessary for doing the research. Without funding, there is no research. Research is necessary. Where you will get the fundings and how you can get the fundings, you have to tell them, yeah, this is the way you can improve your materials. अगर किसी को तेल बेचना हो तो कहना पड़ेगा ऐसे बाल काले हो जाएंगे नहीं तो कोई नहीं खरीदेगा. So we have to tell them this is the demerit with you. You can use this and you can use your material better way in the low cost. Okay. See here this data I am showing you. अभी हम बोले 0.5% में ग्राफ ऐसा होता है, 2% में ऐसा होता है. 2 मिनट बाद आप भूल जाइएगा. 2 मिनट बाद आप ग्राफ बंद. ह्यूमन बीइंग है ना, भूल जाएंगे. I want to tell you how we can do this graph. From this graph, how you can serve to the society, being a faculty, being an engineer. Okay. Next. So these are the graphs I have made it for the carbon fibers and glass fibers, and I try to maintain here, and you can see about the different impact carrying, and we are getting the better. Go to next. This is again you can. This is the showing of the 3.5 meter per second. Next, the showing of the 3.5 meter per second. Next, 4.5 meter second. 4.5 meter seconds. Go to the next. 5.5 meter per seconds. Go to the next. After doing all this, we can say about the 3% reinforcement. It is clearly observed that there is not a sudden failure of the matrix and the laminate, which shows better bonding conditions between the fiber and matrix. See the conditions everywhere 3.5 meter per second, 4.5 meter per second, 5.5 meter per second. Material is going to impact it. Yes, material is going to impact it. Who is load carrying capacity? जो जल्दी से अलग नहीं हो. That means they have the good bond. जो जल्दी से अलग नहीं हो. That means they have the good bondings. If you see the fundamental material science, you can say if I want to separate two materials, if packing factor is good, they have the good bondings. दो बच्चे एक साथ बैठे हैं बिहार के, एक बच्चा बैठा है बिहार का बांग्लादेश का, बॉन्डिंग कहाँ पे ज्यादा अच्छा होगा? जहाँ पे दो बच्चे एक साथ बैठे हैं बिहार के. So if you see the material, if you have the same type of the properties, good bonding adhesion, packing factor is less, strength is more. This concept we are using it here, and we can say this is the best materials because the packing factor is good. Okay. Next. This is the find out how we can find this, how it is damaged and how much the damage, that profile, how much the damage area is that by using the lab facility. This the small things we can find it out. Go to the next. So here this damage area comparison, this will show you how it is going to the damaged. Next. This is the one of the methods. By using these methods, we can also find out the SM scanning. This facility is IC Bangalore. I have also worked here 2 years as a research associate. I am using this facility from IC Bangalore. So this is also the good input for the research. Go to the next. Now coming to the next is validated with the LS-DANA softwares. LS-DANA is an industrial based software. It is the LSTC product. Now it is acquired by the ANSYS. If you purchase the ANSYS, LS-DANA along with that it is available. And you can use this LS-DANA not only for the impact, also if you are doing this practical classes of theory of metal forming. Theory of metal forming also you can introduce this LS-DANA. The job market of the student will become very high.
Now we are using this software with our BTech second year student for that purposes. So go to the next. This is the basic fundamental things considering. Next. Now look at it here. I have told you before going for the impact, these are the data is necessary for doing the software simulations. So these data we have to find out by using this the testing methods earlier before going for the impact testings. These are data is necessary for the software simulations. Next. See the damage, this is the damage, how it is going to the happening by the experimental method, by using happening due to the LS-DANA software methods. See the situations, how much damage area is there. And I can say the difference between the software and the impacted one, the experimental work is not more than 5%. So that means our experimental work quality is going in the right directions. We can simulate and we can see it. Next. See, this is the different type of the simulations of that, different type of the impact energy here at 3.5, 4.5 and 5.5. This you can see the damage area. See the damage area of this 5.5, it's more damage compared to this 3.5, and this all this by LS-DANA softwares. Next. Then you can compare it. This is the damaged one and this is the original one. So you can compare it, how it is going to the damaged one. I have told you just now, before that, 2004, there is no literature review. If it is the damage, how much you can find the stress. How much damage area inside the second layer, inside the third layer. We published a paper in 2004 and we had given the first information in the composite industry. You can find out, yes, damage area is. I'm telling you one very simple story behind this. We have to make a hole there. And you have to make the zinc oxide solution and put it inside. If you heat them, what will happen? Zinc oxide color will become alloys. And the epoxy is going to burn it out and it is going to become yellow. So how much area is impacted? That much area it is going to leave to the previous one layers. So that much stress, that much area is going to become the yellow area. So you can find out, yes, it is impacted from the top one and the layer by layer, how much it is going to impact it because due to the color only. Due to the color only, and you can find the exactly. Now you don't require all this. This is the research I am telling you, 2004, and we published a paper in IIT BHU conference and followed by the Scopus. Now you have the LS-DANA. You can find out how much layer is going to the damaged and how much, what is the thickness for this, because I have told you I'm following Boeing, so my thickness is 4.2. Anybody ask the question, why not 10, why not 6, why not 4? Everything is possible. It is up to you to what you are following. Boeing is a very reputed company. We are following them. So that is a very simple answer for that. But the thickness of that is going to the interface by using this. The layers nowadays it is available with the LS-DANA. See this informations by this damage area of this. Next. Same thing we are following for the different materials. And we can find out CFRP, carbon fiber reinforced. This is the same, we are going to repeat what we are talking for the glass fibers. Next. See the trend of this in the carbon fiber, see the trend of that earlier one. Again you can find out the weight percentage, where is, how much it is going to impact it. Go to next. You just show this information because it's a repeated one. I want to show the differences. Next. See this, the carbon fibers. The carbon fiber, how it look like when it is impacted. See the pyramidal information is that. It is not like the glass fiber because the glass fiber is more damaged. Go to the next. If you see about all this, the comparison chart, and it is showing you where it is, how much energy is absorbed. Next. See how it is going to happen when we take the SM picture and see the damage area of that and how much material is get damaged in the different percentage. Next. Look at it here. I have told you this is the fourth part of the research. Here you can see here how much alkalinization takes place. See the CNTs here. See the CNTs here. How much? See the CNTs here. So if you see about at the exact strength of this, what is happening here and here? Here it is coming and alkalinized in the one place, and see here it is the uniform distribution.
So you have to see about how much percentage of CNT, how it is distributed uniformly, and then it will give the better result. If it is algorithm, it may not be. The next. This is the different type of the pictures, how it is going to the material is going to the break, and we can solve it. Next. Yeah, please. Look at it here. This is again important for you. We started from that, and I have told you, if you see the glass fiber and see the carbon fibers. The glass fiber and carbon fibers, I have told you, the carbon is giving the better result, especially mixing with the MWCNT and the different type of this. Now by doing the 20 years of the research, now the research is focused towards the human. Okay, make the product. Here you look at it here, this is the Munidi mines. And here, if you see about the workers from the mines, after they are going to take retirement, they are not going to live more long life because they have the problem in the knee and the spinals. So we observed that this problem and try to make this. This is the one of the very heart-touching story behind this R&D. And if you distribute it, we have prepared it 20 for this amount for the knee and for the spinal. The worker was so happy. How we can make it? We have to take suppose the different persons have the different weight, height, and then the thickness of that whole body mass index. So we have to take the complete scan of the backbone, and based on that we have developed the mold. And based on those molds, by using these materials, we have to develop this product. If you see about the market, आप कहीं डॉक्टर के पास जाते हैं, कहते हैं डॉक्टर साहब मेरे बैक में पेन हो रहा है, वो क्या कहते हैं, एक बेल्ट ले आइए. You brought that belt in your house, cut and see. We have did so many this type of this experiment. What is inside there? There is some piece of wooden, some piece of aluminum, and some rubbers. There is no engineering. If you see about the best is available in the Amazon, the cost is around 35,000 rupees. If you open it, nothing engineering is behind this. So first time this product is under patent. This two product is now under patent. So this coming here, and it is coming in that way. If you see here, as per the body mass index, we can make the this product for the different persons. Nowadays, when it is come in the market, old people is also asking. When we go for the mass production, we can provide the old people also. If they have the sitting the long hours, they can use this product for the lumbar supports. They can use this product for the knee support. So this is once the age is reaching 50 or crossing the 50, we have to think for society also. So now I am 52. So research should go towards society. Okay, so this two product is already implemented in the industries. Okay, mines industry, we have to made it and implement it. After doing all this, we try to make it. Why not we can make some type of the rods? What will happen in the rods? Nowadays this mild steel, the people is working on that in the mines industries, and once they remove this coal mines, it is very difficult because they have to cut. A lot of cutter is required. So by our fundamental knowledge, we have made this type of the FRP rods in our department. This machine is available in the department, and the project total cost is around 1 CR. And nowadays, only showing no data, I can say the result is also came 10 days back. We are developing the 20 mm diameter rod, and the strength of this compared to the mild steel, 26% better. 26% better. And the load less, there is some physics is behind that, so I should not disclose because again it is patented materials. Again it is patented materials, we have to file the patent for this material and see the future of this. When I made it, after that I have did the testing of how it is going to the compatible with the cement. And when it is put the cement with the 24 hours, we try to remove out from the cement bunch after 24 hours. The iron rod, 27 kilonewtons, we can remove it easily. And for this material, 77. So again, next target is the civil industries. Civil industries. Civil industries, they can give the very good information by using these materials. Only we have, this I cannot say we have did some of the Newton or Einstein work and it is come out. We have to take in some fiber materials and we have to change the design. We have to change the design, and by using the, I can say, this is the magic of mathematics. This is the magic of mathematics. We have changed the design and we can get the better strength of this compared to the mild steel. And the coming future you will find out this. Very recently in August I visited USA, one of the conference, where a lot of paper is related to this. My purpose was there to find out how much they are claiming for strength. We have to find it. Okay? What exactly we are getting the strength for this, I can say definitely it is better than what is available in today in the market. Okay? The next things, it is not, this I told you, this is available now, and we can make it, these rods here also by using this methods. One picture is not put it here. If you see the 20 years back, especially in the Diwali times, lot of ambassador car is coming to the roadside for the denting and painting. Have you find this year? Nothing. सड़क किनारे कोई भी डेंटिंग पेंटिंग के लिए गाड़ी नहीं आता है. The life of that materials, the coating, is nothing but the life of the car. 20 years, nothing is going to happen. 20 years, nothing is going to happen. The answer is TBC, thermal barrier coatings. The answer is TBC. Being a consultant in Swaraj Mazda in Chandigarh, earlier I was in sometime in NIT Jalandhar also, we have to see about how that they are using the TBC, thermal barrier coatings. By looking those concepts, I was thinking, why not I can make a materials? So I can say life of the car is nothing but the life of the brakes. It is came in my mind and we have developed it. The new materials we are developed in the department, and it is both is for the patented. Patent is published. We are waiting for the guaranteed. After publication, sometime it takes for guaranteed. So we are waiting for that. So very soon you will find out from the industry, the life of the brakes is nothing but the life of the vehicles. Okay, so these two patents again from this side, and again I can say the magic of the mathematics with the composites. Okay, so these are the product is already there, and doing this so much work in this area of the research. Some of the things what they have already initially told about me, these are the something, but I am very simple person. आपको हमसे कोई भी काम लगे research related, IT ISM का rule follow होना चाहिए. I will definitely help you. Thank you very much for this. Anybody have any questions? Yeah, please.
माइक पास करो. अरे यहाँ सर के पास.
मैं वहाँ जाऊँ.
You have shown some the composite rod, I think, application. So used by the some miners workers.
Which?
The knee for knee support, knee and backbone support.
I have used it for the miners in the mines. Yeah.
So, is it the material here? What is the novelty? Material or the design?
Design and material both.
So earlier the composite materials were not used for such.
Not used for that. They are used this pieces, aluminum pieces, and sometimes we have purchased a lot of from the Amazon. They are using the aluminum pieces or the wooden. So this is the beauty of the composite. And also if you see the product, actually I was planning to bring that product, but we are waiting just for patent. And you can see this, suppose now my height is different to our friends. So if you see the height of that, our L3 and L4 have the different layer of that. So if I want to make for them, I have to set it according for his height. If you want to make for me, I have to set according to my height. Then inside, we have to put the 3 layers. The center layer is equal for everyone. Where is your problem? In the L3. We have to bring this and put it in the L3. So when you sit on the chair, the L3 will support them. So if the long lasting, again that problem will not come up. We have experimented it unofficially. The ex-director, I have given him for a week, and sir have used it and returned back.
Then I given one product to one assistant registrar, Sivji Pandey. They have also used it and returned back. They are very happy. So once it is patented, after that we contact some of the industry, and it is not only for the mines workers, it will see for the all the workers and also for the old people.
सर पहले डिजाइन में भी सर सेम आता था पहले से यूज होते रहा है मेडिकल इंडस्ट्रीज में
जी सर
नंबर सपोर्ट के लिए भी नी सपोर्ट के लिए भी या कई डिजाइन हमारे हैं यहाँ पे होते हैं
जी
तो उस डिजाइन में जो पहले से यूज होते थे और अभी में दोनों में क्या चेंज है
सर देखिए पहले से जो यूज हो रहा है अभी जो अगर आप इसको देखिएगा ओपन कर कोई आपके ह्यूमन की बॉडी के हिसाब से डिजाइन नहीं किया वो ठीक कर लिया है कि ह्यूमन बॉडी ऐसा होता है ये मेरा प्रोडक्ट है हम क्या कर रहे हैं इसमें कि जैसे सर हमारा वेट आपका वेट और इनका वेट अलग अलग है तो हम वहाँ पे वेट
Sir, my question is regarding nowadays the Air Force is moving toward the hypersonic.
Yeah, yes.
So what will be the future of the composite material in the hypersonic field?
The future of the composite materials in the hypersonic, if you see about nowadays, if you see this carbon fibers, the carbon fibers or the now say the supersonic or the if you see the BrahMos missile, the BrahMos missile director for the India is Professor R.K. Singh. He was one of my thesis supervisor in my PhD. So if you see the BrahMos missile and all this, you will find out they are using these materials in these carbon fibers, but nowadays they are using also the carbon blends and all this. So that if you see about the multi-wall carbon nanotubes, CNTs, if you improve the strength, because the Boeing is using this type of the NDR, along with the MWCNT and make it the more tougher, more stronger, more durable. We are thinking towards that. Very recently, I attended one meeting in IIT Kanpur. How the Uttar Pradesh has become the Uttam Pradesh. So there, this type of the DRDO has come and made all these things. So this type of things is already I reported to the highest level of authority in the DRDO. We are waiting for his reply. If any reply will come, I will circulate it in the upper groups. Okay?
Yes.
Anybody have anything?
Yes sir. आपने बोला सर कि CNT का जो है जो ये बेसाल्ट फाइबर से करेंगे तो जो उसमें ब्रीजिंग एक्शन जो होता है सर है ना उसको कैसे कम करेंगे क्योंकि जो उसका एस्पेक्ट रेशियो जो है CNT का बहुत हाई होता है ना तो बेसाल्ट का कैसे
देखिए CNT में क्या होता है if you go with CNT initially if you see about CNT people are taking it and making it by the hand आप इसको अल्ट्रासोनिक मिक्सिंग तक जाएंगे if you go for the ultrasonic mixing and again at the same time the preparation should be ready and if you take it from the ultrasonic mixing nothing will happen.
सर हम लोग किए हैं अल्ट्रासोनिक मिक्सिंग तक भी किए हैं लेकिन आपका जो है सर जो एग्लोमेशन है वो 4% के बाद आ रहा है लेकिन हम लोग जो किए थे वो 1.5% के बाद एग्लोमेशन आ जा रहा है.
आप एक काम कीजिए आपको ना मटेरियल लगेगा ना किसी से परमिशन लेना पड़ेगा आप मेरे पास मटेरियल भी है लैब भी है उसको रिपीट करके एक बार देख लीजिए. आई एम इनवाइटिंग यू.
ओके सर सो ये इट में भी जी सर थैंक यू.
और हम क्या बोला
इट में भी सब प्रोसेस का भी
हाँ हो सकता है प्रोसेस में कहीं कहीं को लीच हो सकता है कि कुछ ना कुछ प्रोसेस में प्रॉब्लम हो क्योंकि सबको एक साथ लेके चलना पड़ता है क्योंकि हम लोग इसमें बहुत काम किए हैं है ना. तो जब पहले स्टार्टिंग में देखिए जोगाड़ टेक्नोलॉजी शुरू किया आप देख लीजिए कैसे कैसे मेटल बनाया हमारे पास मिक्सिंग नहीं था तो मिक्सिंग का क्या किए हेयर ड्रायर खरीदे मार्केट से वो भी बता रहा हूँ आपको और हेयर ड्रायर के अंदर जो घुमाने वाला था उसको निकाल लिए और उसको बीकर में डाल के मिक्सिंग करते थे है ना. See the starting from there 2009 and then we reach up to this level what we are today.
सर वो फंक्शनलाइज भी होता था क्या कुछ
फंक्शनलाइज का लेकिन लिमिटेशन है. फंक्शनलाइज MWCNT नहीं MWCNT का जो फंक्शनलाइज है वो डिपेंड करता है किस टाइप का आप रेजिन यूज कर रहे हैं है ना. अगर आप पॉलिस्टर रेजिन यूज कर रहे हैं तो दुनिया भर का प्रॉब्लम है. अगर आप इपॉक्सी यूज कर रहे हैं तो प्रॉब्लम नहीं है. अब पॉलिस्टर का बेनिफिट क्या है ये भी बता देता हूँ. जब पॉलिस्टर में आप रिलीजिंग मटेरियल डालिएगा तो पॉलिस्टर इज गुड. सो वेयर आई शुड यूज द पॉलिस्टर वेयर वी आर मेकिंग द रॉड्स वेयर आई गोइंग टू यूज दिस इपॉक्सी वेयर यू आर गोइंग टू डू द मैकेनिकल टेस्टिंग मींस टेंसाइल कंप्रेसिव फैटिग क्रीप फ्रैक्चर.
ओके सर थैंक यू.
ठीक है. सो एनीबॉडी
want to ask question?
So thank you so much for patient listening to me, and I hope we'll meet again.
Thank you so much, sir, for such an insightful talk, starting from the type of failure and mechanism of failure to the patented design and material. Sir, we are also thankful. Sir, we are also thankful to you for developing such a well-equipped world-class laboratory for us. Moving to the next, we have a special guest, Dr. Sushil Kumar sir from Medical Science. He is a dental surgeon and founder of Elevatronics Private Limited. He has developed assistant-free dental suction system in collaboration with Professor Karadi Patra sir at IIT Patna. The company is incubated in Incubation Center IIT Patna and received fund from Startup Bihar BIRSC. I would like Dr. Shambhu Kumar to felicitate Dr. Shashi Kumar sir. Thank you so much, sir, for joining us. Now, moving to our next invited speaker, we have Dr. Rakesh Kumar sir, Associate Professor, Department of Mechanical Engineering, IIT ISM Dhanbad. Sir has completed his BE from RPSIT, Patna, MTech from National Institute of Technology, Patna, and PhD from IIT Patna, IIT Guwahati. Sir is working with IIT ISM Dhanbad since 2012. Sir has guided more than 20 PhD research scholars, out of which more than 10 has already awarded his degree, and rest are in the advanced stage of completion his PhD. Sir has guided more than 30 MTech projects. Sir has published more than 60 international journals in SCI and Scopus Index. Today, sir is going to deliver his talk on the topic thermal performance analysis of cavities-based solar air heaters. Rakesh sir, please come forward for your talk.
So good morning to all. So my topic is based on thermal engineering and heat transfer. And in this topic, I will try to discuss if you will disturb flow field, then how we will get achievement in the heat transfer and how we will try to utilize achievement in different applications. And my topic is based on solar air heater. So this topic is basically based on heat transfer, three different modes: conduction, convection, and radiation. So convection means heat transfer occurs due to movement of the fluid. Conduction means heat transfer in any particular body, and radiation means heat transfer between two bodies. So next. So today I will discuss first introduction part, then some literature review, research gap, objectives, and then conclusions. Next. So actually heat transfer play very important role. So if you will utilize this heat transfer, then you can use in different application to producing power as well as heating purpose. So this heat transfer, basically you can improve with the help of two different arrangements. One is your with the help of extended parts. Extended part is also known as fin, and another is due to with the help of cavities. So in automobile sector, we using extended part fin for cooling of any engine, and in solar air heater we doing to form cavities to disturb flow field and increase heat transfer rates. So here in with the help of cavities, we can reduce pressure drop, easy to manufacture, your uniform cooling, as well as we have removed weight, therefore we can reduce weight of the body. But in case of extended part, first problem is pressure drop, because it becomes very difficult to maintain uniform flow field. And another problem is manufacturing, because you can manufacture only with the help of casting process. To increase heat transfer rate. Next. So here its application I will use first in the solar air heater. So you know very well, solar air heater is generally used to increase temperature of water or temperature of air or temperature of any fluid to increase in the different applications. And here main important term is convective heat transfer, because here fluid particle comes in contact with the plate, and when absorbing heat, then temperature of the fluid particle decreases. Temperature of the fluid particle increases, density decreases, and due to low density, fluid particle easily flow. And easily flow, then again fresh air or fluid particle comes in contact with the surface and absorb heat. Next. So here its application I will also discuss with you in the PV cell, because you know very well in the solar heat engineering, PV is used to produce electricity in the rural area as well as in the urban area. Next. So main problem or difficulties with your solar PV cell is temperature. If temperature of the PV cell increases more than 25 degree, then its thermal performance decreases. So here I will discuss when solar heater attached with PV cell, then it becomes PVT, means photovoltaic thermal air heater. So here with the help of movement of the fluid particle or air particle, we try to decrease temperature of the PV cell, and this temperature of hot gases or hot air, we try to again increase temperature of the heater. Next. So this is your PVT. So the word PVT is coming by assembly of PV cell as well as solar air heater, and the purpose of both is to produce electricity uniformly as well as increase temperature of fluid particle. Next. So here this is one schematic diagram. So here fluid is flowing below the dimple surface or below the solar air heater. So here solar air heater first absorbing heat from the PV cell and then transfer to the air. Here is moving with the help of lower or density difference. Next. So here is another one schematic diagram of the PVT system. Next. 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 So different researchers also published different papers on the solar air heater as well as PV to estimate the optimum mass flow rate, construction of dimple photovoltaic thermal system, and then thermal and electrical performance analysis of PVT cell. Next. So here you see first I have compared two plates. One plate is made of dimple. So dimple means cavity. Here this plate is made of cavity, and here this is simple plate. Both are made of same material, aluminium. So here this is one simple glass tube. Here simple glass tube to remove dust particle, and here this space is available to flow air particle. And this is a small space, and these are some measuring instruments I have put to measure mass flow rate of air particle, temperature difference, as well as heat transfer. That when you are supplying constant heat flux then on the PV cell, then thermal performance of the PV cell increases with the help of dimple based solar heater, as well as dimple based solar heater performance also increases compared to your conventional as well as your flat plate solar heater. Next. So here again you see the temperature difference is less compared to dimple plate solar heater. Next. So here again your power output is other arrangements. Next. Electrical efficiency of flat plate is more compared to your flat plate and conventional system. Next. Temperature difference is also increases temperature. This is your efficiency. Thermal efficiency means output by input. So thermal efficiency is also increases compared to the PVT cell. Next. So daily thermal efficiency you also see when you are supplying constant heat flux with minimum losses, then your performance also increases with dimple based PVT. Next. So conclusion. So the PV cell performance increases as well as with the help of movement of circulation or circulation of the air or disturbance of the air, your performance of the PV cell also increases compared to all other types of arrangements. Next. So overall conclusion between dimple plate solar heater and flat plate solar heater. So the thermal efficiency of solar heater have been enhanced by creating a spherical dimple roughness in the absorber plate. Quantity so that the temperature difference, average extracted power, heat transfer coefficient, instantaneous efficiency and effective efficiency of the dimple plate solar heater is more compared to flat plate solar heater, and the change in effective and temperature difference of dimple plate solar heater and flat plate solar heater for mass flow 0.047 kg per second onwards is very small. Next. So these are another conclusions. So these are overall conclusions between dimple plate solar heater and flat plate solar heater. Next. So here again I am using same experiment with the help of PCM, because here temperature of air increases. So this temperature of hot air we try to increase or try to store sensible as well as latent heat with the help of PCM material. Because if PCM material absorbs heat, then next time if suppose temperature is less, then with the help of PCM material which can supply to any other place. So here in the same experimental setup, we try to receive as well as utilize heat in three different ways. First with the help of PV cell, second with the help of solar air heater, and third with the help of PCM. Next. Okay, next. So thank you. So if you have any question regarding solar air heater or PV cell, then please tell.
If you have any question.
Regarding the intensity of solid in your experiment, which reason you have selected for your study? You have selected for only thermal. Is your result will change with the location?
Location will, because humidity also important.
Okay.
If humidity and intensity will increase also. Okay. As well as in the Jharkhand area, thermal pollution is also more. Dust particle is also more.
So that will also.
And this experiment I have performed between November to March, because average intensity, because from April to October very high intensity.
Yeah, but you will get maximum intensity of sunlight in May to August.
Therefore, the performance of the PV cell decreases.
Okay.
But in the Europe countries,
yeah,
you will note intensity maximum people are using PV cell.
Yeah.
But in the India, temperature fluctuating.
Yeah. So
very high means suppose in the Bihar or Patna, and the summertime around 45-46 degrees. In the winter time below 10 degrees. So it becomes very difficult to maintain any instrument or machine.
do you have solar defibrillator also to? Okay. 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 Thank you. It was a nice presentation. Thank you.
Thank you so much, sir, for your insightful presentation. Moving to next invited lectures, we have our next speaker, Dr. Piyush Kumar. Dr. Piyush Kumar is currently serving as an assistant professor in the Department of Aerospace and Mechanical Engineering at the University of Texas. Prior to his current role, he held a position as a research scientist associate at UTEP, where his primary focus was on developing computational fluid dynamics based heat transfer models for hypersonic flow phenomenon. Before joining UTEP, Dr. Piyush completed his PhD in mechanical engineering from the Indian Institute of Technology, Patna in 2022. During his doctoral studies, he conducted extensive research on the dynamics of droplet generation within microfluids devices. His work significantly advances our understanding of fundamental fluid dynamics in microfluids and its application potential, particularly in the area such as drug delivery system and high throughput biochemical analysis. Dr. Piyush, sir, you may continue with your presentation now.
Thank you for such a nice introduction. Thank you for nice introductions, and good afternoon, everyone. I am Piyush. I am currently working at University of Texas El Paso as assistant professor in the Department of Aerospace and Mechanical Engineering. And today I will be presenting on the role of the nanoparticle concentration in droplet microfluidics. So first we will take what is microfluidics. In microfluidics, basically we deal or manipulate very small volume of the fluid in the microliter, like 10 to 20 microliter volume of the fluid. So one of the basic application of the microfluidic in your day-to-day life, you will see the COVID testing machine, where we take the sample of the blood and we go through the different polymer chain reactions. And based on the sequential reactions, we find whether you have a COVID or not. And another one is the pregnancy testing machines, which is basically a paper-based microfluidics. In the pregnancy testing machine, we take the urine, and based on the urine, we see whether the women are pregnant or not. So in the microfluidic systems, one subcategory is the droplet-based microfluidics, in which the droplets are formed by using the two immiscible liquids. And this droplet can be further used in the mixing
Hello.
double emulsions.
Bro, is online presentations going? But I joined using the link. But their offline presentations is going.
Hello, sir. Am I audible?
Hello.
Sir, am I
Hello.
audible to you, Dr. Kumar Swami? Okay.
Hello. Hello.
Yeah, it's clear. Please
Hello.
go ahead. I'm listening to Dr.
Hello.
Priya's presentation.
Okay. So we have currently going with the invited speakers talk. After once
Hello.
the invited talk will finish, we will continue with the participant presentation. So most probably in the second half, your schedule will be planned. Am I clear? Okay, sorry for the inconvenience.
Okay, no problem.
Hello. Yeah, I joined using the link. Oh, what? Yeah, I used the link where the link is shared in the group. Yeah, A068.
Hello, 068.
Then which track I need to join? Okay. Okay, I will say hi.
You may wait for the time being. We are ongoing with the invited lectures. In the second half, your presentation will be scheduled. Till then, you can message us on the group that we have created for any clarification.
మంచిది పాజిటివ్ ఎనర్జీ సరే ఇప్పుడు
Okay, so they want me to finish as soon as possible. So, okay. So these droplet forms can be used in the mixing on double emulsion formations or some of the particles. And some of the particles, go next. Some of the particles, and this droplet can further be used in some of the applications like biochemical or material synthesis, drug discovery, or chemical reactions. In all these applications, the size of the droplet, we have three passive methods to control the size of the droplet. One is by using the co-flowing device, and other one is by using the flow focusing device. So there are three passive methods to control the size of the droplet. One is co-flowing, second one is the flow focusing, and third one is the cross-flowing method, which is also known as T-sections. So my research will basically focus on the T-sections, which is simple to construct and easy to manipulate the flow behaviors. So in the T-junctions, we have two channels. One is known as the primary channels or the continuous phase channels, and second one is the secondary channel, that is the dispersed phase channels. In this one, the two fluids are immiscible. So the continuous one will help in the formation of the droplet, and this dispersed phase from which the droplet will be formed. So we maintain the sum flow rate at the inlet by using a micro syringe pump, or if you are doing the numerical modeling, we put the boundary condition as the inlet flow. And then when this dispersed phase goes inside the continuous phase, try to block the flow of the continuous phase. So due to this blockage, you will see that there is a pressure difference across this dispersed phase. This pressure difference will help in droplet breakup. So when this pressure drop becomes more, this thickness of the neck will goes on decreasing. And when the thickness approaches zero, the formation of the droplet will take place. So basically in this droplet formation, we have three forces responsible. So one is the drag force, which is imparted by the continuous phase fluid on the interface of the dispersed phase. And the second one is the pressure. Pressure is due to this blocking of the dispersed phase, blocking of the flow of a continuous phase by the dispersed phase fluid. And third one is the interfacial tension. This interfacial tension try to resist the breakup of the droplet. So when the shear force or the drag force plus the pressure force becomes overcome this surface tension force, the formation of the droplet take place. So in the microfluidic T junctions, we have three regimes of the droplet formations. Next. We have three regimes of the droplet formation. So first regime is known as the squeezing regimes. So in the squeezing regimes, the dispersed phase completely touches the continuous phase channels. And in the dripping regimes also, you will see there is a partial gap between the channels wall through which the continuous phase fluid flow. And in the squeezing regimes and the dripping regimes, the formation of the droplet will take place at the junction. But in the jetting regimes, you will see the droplets are formed far from the junctions, and which is highly unstable conditions. So we want to avoid this one, jetting regimes. So this formation regimes basically depends upon the capillary number, and capillary number is again a non-dimensional number, which is basically a ratio of viscous force divided by surface tension force. So next one. So in this one study, I want to focus on the nanoparticle consideration, how this nanoparticle will affect the droplet formation in the microfluidics. Because if you mix nanoparticle with some of the base fluid, some of the nanoparticles will act as the non-Newtonian fluid. So I have taken, in most of the applications, the fluid we use is the non-Newtonian, like the blood, which is also non-Newtonian fluid. So some of the studies, by using the silicon oxide as the nanoparticle with the water, they see that they are non-Newtonians, and the apparent viscosity increases with increase in the nanoparticle droplet formation, like the viscosity, density, droplet formation like the viscosity, density, and contact angle. Contact angle is basically wettability with the channel wall, and the interfacial tensions. So if you are using two immiscible fluid, we have to calculate the interfacial tension. So next. So for the silicon oxide nanofluid, these are the purity which is supplied by the sigma Aldrich, and the size of the nanoparticles form nanopowder, and the color is white. And to prepare this nanofluids, we have first ultrasonicated. Initially we use the rheometer to calculate the viscosity. So initially we have calculated for the DI water, and we see that the viscosity is around 0.001, which is same as the literature. And then we have also calculated the viscosity same as the literature. And then we have also calculated the viscosity of silicon oil, which we have purchased, and the viscosity was around 0.009, so which is also same as the literature. And then we have calculated the viscosity of three different concentration nanofluids, and we see that from this one, these nanofluids basically behave as a pipe, and nanofluid, we have taken the pendant droplet, and this image is further visualized by the open drop software, which is used to phase. Another one is for the disperse phase, and we have a high-speed camera to measure, to see the flow, to visualize the flow, and we have a light source to illuminate the image, and we have a computer to record this video during the droplet formations, and we have a drainage. So during the droplet formation, first step is to calculate the different regimes of the droplet formations. So this is with the water, and this is with the 2% silicon dioxide. So we have a three regimes: squeezing, dripping, and the jetting. So these regimes you will see at the lower flow rate ratio, flow rate of the dispersed phase divided by flow rate of the continuous phase. So at the higher flow rate, you will see this regimes squeezing. If you increase the continuous phase flow rate, the size of the droplet decreases, and if you see at the increase the concentration, the size of the droplet will also increase, because more viscous nature of the fluid will try to resist the deformations. And this is for the total time. With the continuous phase fluid, the time of the droplet formation decreases if you increase. Next, this is the dispersed phase. Now we have changed the flow rate of the dispersed phase fluid, and continuous phase flow rate kept constant. We see that the size of the droplet increases, and the frequency of the droplet formation also increases with the increase in the continuous. Because if you increase this flow rate, the momentum, the inertia of this phase increases, so the size of the droplet increases, and the frequency of the droplet formation also increases. Next, this is the same, size of droplet increases, and the frequency of the droplet, means when you increase the dispersed phase, the formation time decreases. Formation time decreases, which means the frequency of the droplet formation increases. Next one. So we have done our fitting to see how this length vary with the flow rate ratio. So we see that for the water, this constant value increases with the nanoparticle concentrations, and the power is same in both all the equations. So the length of the droplet will increase because this constant increases with increase in the concentration of the nanoparticle. So the next one is the conclusions. So we have used silicon oxide as the nanofluid to see the droplet formations. Silicon oxide based behave as a non-Newtonian fluid, which is a shear thickening fluid, and the contact angle and interfacial tension increases with the increase in the nanoparticle concentrations. And as you increase the disperse phase flow rate and decrease the continuous phase flow rate, the increases the droplet size, and the droplet formation time decreases with increase in the continuous phase and disperse phase flow rate. And droplet formation in the shear thickening fluid often takes more time than the Newtonian fluids that we have seen in the graphs. Okay, next one. These are the references I used to make these presentations, and I acknowledge Professor Pathak sir for this work. We have done this work with them, and thank you for listening, and thank you for the invitations. If you have any questions.
So if you have any questions, you may ask, or you can interact during the lunch session.
Okay, thank you.
Thank you so much, Dr. Piyush, for the wonderful lectures. Sir, जुड़े हुए हैं, शंभू सर? Sir, जुड़े हुए हैं?
Sir, are you here? Bhakar sir? Bhakar sir? Bhakar sir?
Oh, yes, sir. Yes, I can hear, please.
Volume बढ़ा लो. Okay, so moving to the next lecture, we have with us Dr. Sudhakar Kumaraswamy sir. Sir is an associate professor at the Faculty of Mechanical Engineering and Automotive Engineering Technology, and a principal research fellow at the Automotive Engineering Center, University, Malaysia. He had held his permanent position at Energy Center, Maulana Azad National Institute of Technology, Bhopal, India, where he coordinated the master program in green technology and renewable energy. Sir has completed his PhD from National Institute of Technology, Tiruchirappalli in 2013 with the support of SRF Fellowship. Sir has held several visiting adjunct positions in Russia, Vietnam, China, and Indonesia. Sir has supervised more than 10 PhD students and more than 45 master projects, both in Malaysia and India. And currently he is leading a team of 15 members consisting of PhD, masters, and undergraduate final year students. He has more than 250 international publications with a very high H index of 69 on Google Scholar, 58 on Scopus. Sir has been placed among the world top 2% of scientists for 6 consecutive years from 2020 to 2025. Dr. Kumaraswamy is an active reviewer of more than 100 international journals published by Elsevier, Springer, Tiller and Francis, and etc. Sir has been awarded by Climate Leader Award in 2010, Madhya Pradesh Young Scientist Award in 2012, Young South Indian Researcher Award on Sustainable Consumption and Production by TERI University in association with the UNEP in 2016, and UNEP Vice Chancellor Kennedica Bitara Award for the year 2018 to 2022 consecutively. Dr. Kumaraswamy, now we are ready for your insightful lecture. Kindly share sir's presentation. Sir, you can share. You can now share your presentation.
Okay, sir. So, yeah, very good afternoon to all of you. I hope the slide is visible.
Sure.
Okay. Distinguished colleagues, ladies and gentlemen, first of all, I would like to thank the college for inviting me to deliver this talk on the first international conference on advanced trends in engineering and emerging technology. I understand that is the first international conference, so it's always privileged to be part of such initiatives. Today, I would like to talk something about offshore renewable energy and green hydrogen production, which is going to be one of the transformative future, not only for India, it's also for countries with large, vast coastline. There is enough potential to generate renewable energy. At the same time, can also meet our fuel energy requirements. So let's quickly move on to the introductory part of it. So currently there is a interest more on net zero goals and decarbonization. And this is not just a dream, it is going to be a reality. And we are not very far away. By 2030 and 2045, we have a lot of targets to set net zero. To achieve net zero or green energy transition, it is not just possible only with electrification. We need to move away from think about diversifying our energy sources and also going for other alternate forms of energy. So there, one source which would be viable and which is also practically feasible is a hydrogen. And why hydrogen? Because it is not always possible to decarbonize the heavy industries, especially steel, cement, shipping, aviation, and all these sectors, all these transportation sectors and heavy industry sectors. Electrification alone is not at all possible. So we may need to think beyond electrification. There, the gap lies in forming a new fuel, which is green hydrogen. And is also with a lot of rapid renewable energy growth, there is always an intermittency and grid limits with respect to expansion of renewables across the globe. So there, green hydrogen can be one of the solution to overcome this intermittency as well as the grid limitation of renewable energy growth. So let's move on to the topic, why green hydrogen? Because green hydrogen is going to be a multi-purpose feedstock. It can be a fuel for transport and mobility. It can be a fuel for power, which is for electricity generation as well as peak demand peaking plant. It can be a feedstock for many industries like steel, cement, paper, food industry, aluminum, and so on. And it can be used as a feedstock for agriculture, fertilizers, building, and also it can be a fuel for heating, for cooking, as well as for other industries as well. So basically, it has a versatile form. Thereby, it has got a very good potential. But unfortunately, the current green hydrogen is only contributing less than 1% of the production, which is roughly coming. Most of the hydrogen is actually coming from fossil fuel-based sector. And also there is a low electrolyzer capacity as of now, only 5 gigawatt of electrolyzer capacity across the globe with less effective utilization is there. And also the current production cost of green hydrogen is around in the range of 5 to 7 kilogram per liter, which is also very high. And they want to bring down to a cost of USD 2 to 3 kilogram per liter by 2030. And the electricity cost and capacity factor is also greater than 60% of the total hydrogen cost. So meaning that if electricity price comes down, the renewable energy cost, then naturally the green hydrogen cost may come down. And then the capacity factor of the renewable plant also have to increase. increase, thereby this total production cost can come down. Currently, the demand for low carbon hydrogen is projected only 4 to 5 million tons per year. But this also going to increase roughly around 400 to 500 million tons by 2040 and 50. So there is a huge demand for green hydrogen, and it's as I said, it's a versatile fuel which has got a lot of application in several sectors. So basically, we need to look at this fuel very seriously. So there is a demand to reach 500 to 700 million tons of hydrogen by year 2050. And we need to go for large-scale decarbonization and energy transition, which cannot be achieved only by electricity. We need to think of other aspects as well. There comes this opportunity, which is offshore wind and solar, which can offer a hybrid scalable energy solution to overcome the intermittency issues. At the same time, can also produce a green fuel. And green hydrogen enables conversion, storage, and flexible use of renewable energy, because we know that solar and wind are unsteady. To make this intermittent source to a steady and concentrated source, the green hydrogen can exactly fit into it. And the variable renewable energy power always leads to power curtailment, and which may not be able to overcome in certain cases. So thereby, green hydrogen can be one of the intermediate between these points. It also enables energy conversion, storage, and transport flexibility. So this is why we look at this study. So let me move on to the next aspect. So as far as offshore renewable energy resource characteristics, we know already offshore land-based wind energy system is quite popular in India, especially in high windy regions in part of Madhya Pradesh, Gujarat, Tamil Nadu, and other parts. We have enough land-based wind power plant which are very successful, and it does have a capacity factor around 35 to 40 around, which is closer to the BEDS limit. And whereas if you go for offshore technologies, there is a continuous wind in the ocean, deep in the ocean. So thereby the capacity factor can increase until 45 to 60%, which will be significantly higher than the onshore power plants, which is quite underutilized, considering the vast coastline from Maharashtra, Gujarat, this side, if you take Karnataka, Kerala, this side, Tamil Nadu, Andhra Pradesh, Orissa, West Bengal. I think there is a huge potential to harness offshore wind and also contribute to the complementary nature of wind and the electricity demand, and all these things can be overcome with the help of offshore wind. And slowly floating is also quite a very interesting success story in many of the lakes, rivers, canals in India. And this can also be applied in ocean conditions where we can also improve the efficiencies, and this can be co-located with the offshore wind. Thereby, the intermittency issues can be avoided and capacity factor can be enhanced. So there's a hybrid offshore wind and solar systems can actually reduce electrolyzer idle time by 12 to 18%, thereby improving the utilization rate of both the energy. So this is why we need to look at it. And for the transmission of renewable energy, let's say we only focus on solar and wind energy system in the ocean. We want to transfer this electricity through cables to the land. This is going to be very, very expensive, because beyond certain kilometers, let's say it's around 80 to 100 kilometers from the shore, the power transmission cost is very, very high, which is not reasonable. Of course, if that is very less distance, then the transmission of power from the ocean to the land is economical, but beyond 100 kilometers, it is not at all economical. Thereby, it can be converted into a hydrogen fuel, and then power to hydrogen can be a more cost effectiveness than transferring this electricity to the land. Thereby, we can actually meet the fuel requirement of shipping, and it can also transfer easily through pipeline. So that is what they say. So the transmission limit is playing a very important role in the case of electricity aspects. So when we think about offshore solar and wind, naturally we need to look at hydrogen as the fuel rather than transporting the electricity from the ocean. And green hydrogen, if you think about it, we need to have clean water for its production. So thereby we need an electrolyzer to convert the water into hydrogen. So this offshore electricity from can be used to electrolyzer, and then we can actually produce hydrogen. But again, the choice of electrolyzer and the salt water should be purified. The desalination unit is very important as a part of offshore energy systems. And then comes the long-term storage. So how long we store? Do we store it in the ocean itself, or we transfer to the land through pipelines? So these are all going to play a very important role in net zero targets. And converting offshore power into a controllable chemical form. What does this green hydrogen offers? Because this offshore intermittent power, we are able to convert into a controllable chemical energy, which can be stored and which is very durable and which can be used any instant of time. So that is the advantage with the offshore requirement, with offshore energy. For the electrolyzer technologies, normally we have three types of electrolyzer which are already commercialized, which is alkaline electrolyzer, proton exchange membrane electrolyzer, and solid oxide electrolyzer. Among all these electrolyzers, proton exchange membrane electrolyzer for offshore condition is very suitable. Why? Because in offshore we need a very compact and low weight design which can be fixed on a platform itself, and should have a faster response to the variable renewable energy power, because the solar and wind are very variable, but the electrolyzer should have a fast response to the variable nature of energy. And this electrolyzer also should have a high reliability in the marine condition, because it is prone to corrosion, prone to extreme temperatures sometimes. So all these things are very important aspects when we consider the electrolyzer. So when we compare all these electrolyzer for offshore condition, a proton exchange membrane electrolyzer, which is operating at the ambient temperature, which is less than 40 to 50 degrees centigrade, which is suitable for this offshore condition. Solid oxide electrolyzation has a better efficiency, but requires operating condition very high and lead to thermal degradation and so on, not suitable. Alkaline electrolyzer is also mature and low cost, but they have a slow dynamic response. So that's why it is not preferable for the offshore conditions. So a lot of research has been done, and they finally found that proton exchange membrane electrolyzer dominates the offshore systems because it operates efficiently under fluctuating weather and solar condition. It has got a high utilization factor and can be easily integrated into the offshore platform systems. And when we do the techno-economic evaluation, we found that levelized cost of hydrogen production by using PEM electrolyzer has economic advantage compared to the other two types of electrolyzer. Thereby the operational energy loss reduction and wider performance are achieved in the case of the PEM electrolyzer systems. Now let's move on to the entire configuration, the entire architecture of such systems. If you can see this picture, you will find a conceptual image where you will have offshore wind energy systems. You have a floating solar array systems. So when we have a floating solar and floating wind, and then it can actually increase the capacity factor, because when we consider solar alone is only 50 to 20% efficiency. And when we have a wind systems, it will have 30 to 40%. So all these things, we will have a better utilization ratio, so which may even reach 60%. So that is the advantage with the hybrid systems. And this can be put on a common platform where we will have an electrolyzer unit to collect the seawater and convert into a purified water. The same electricity can be used to purify it. And this pure water can be used in the electrolyzer, which is proton exchange membrane electrolyzer, and produce green hydrogen. And this green hydrogen can be stored in the ocean platform itself, because it can also act as a refueling system for the ship and ferry which is moving in the ocean. Be transported from the ocean to the land for refineries and for utilization in the land. So it can be sent through pipelines or other methods to deliver the power. It's basically a power to X or power to hydrogen concept, where this kind of configuration is totally deployable, because we have a lot of oil and gas infrastructures in many parts of Maharashtra, then oil rigs. I think these technologies, we have enough exposure to the oil and gas infrastructure. The same oil and gas infrastructures can be used to deploy this hydrogen hub, where we can actually produce green hydrogen from the ocean at a very compatible manner using the existing infrastructures. The system sizing is very important, because if you see this picture, the previous image, it involves a lot of individual units, which is the solar and wind systems, and the storage unit, electrolyzer unit, and the transportation unit. So problem here is not about individual system. It is all about integrating the systems and doing the appropriate sizing of all these systems. So there lies the challenge of how do you integrate all the systems and what would be the sizing of individual systems. So that is going to play a role in the cost of green hydrogen production. Of course, the desalination people used to consider as one of the problem, but it is not at all an issue because hardly the desalination requires 1 to 2% of the total energy consumption. It is not at all a limiting factor when we consider desalination. It is about the capacity sizing of the renewable energy. So it is always good to size the renewable energy comparatively larger than the electrolyzer system. Let's say if we have planning for a 20 megawatt hybrid system, then your electrolyzer can be much smaller, but basically your renewable energy system should be much larger in capacity so that you can match with the electrolyzer capacity. And centralized platforms are always offer superior reliability and maintainability compared to the system because of reduced mechanical stress and safety management. So this is about the system design. Then we look at the challenges and opportunities about this integration of offshore green hydrogen systems. Mainly, it is coming with the factor of variable renewable energy because solar and wind, though it is still in the ocean condition, it may also have a reliability issues because you want to have power 24/7 and you want to operate the electrolyzer also 24/7. So there may be some kind of reliability issues with respect to the renewable energy. And the electrochemical conversion, the electrolyzer degradation and its operating condition in the ocean environment, this is all going to be a very important issues. And then the harsh marine environment like wind, storms, cyclones, and corrosions and fatigue. This also should be considered as a factor because this plays directly an important role on the maintenance of all these systems as a whole. So this is one of the core challenges with the technologies. And of course, the challenges are interrelated and they are system-wide. And this can be actually addressed very easily with the component optimization. As we integrate all the components, we can actually optimize the sizing and come up with a better configuration to achieve the desired output of hydrogen energy. And the system level integration is very, very essential when we study the whole system together. Okay, so let's move on to the further challenges, which is related to the electrolyzer part and the catalyst aspect, membrane thinning, increased chromic resistance, accelerated mechanical wear. So these are all very intrinsic related to the electrolyzer unit because they degrade very faster. And there is a membrane replacement, proton exchange membrane replacement, thinning. These are some specific related to the electrolyzer part. And this can be addressed with proper operational strategy and proper selection of electrolyzer and proper material. This can be actually addressed. Moving on to the overall comparison of challenges. So reliability challenges is on the solar and wind side, and limited accessibility for maintenance because when you want to maintain the system, sometimes it is deep ocean, so it may have some limited accessibility. And if you want to repair and service in the ocean itself, it may be very challenging, which leads to high cost. There is a critical risk to the infrastructures because they are corrosive nature. There can be a hydrogen leakage, hydrogen embrittlement when you transfer it through pipelines or through compressors, or when you want to storage through the storage vessels. So there is a possibility of hydrogen embrittlement. And environmental stresses because you are surrounded by a harsh environmental conditions like salt water, high humidity play a very important role there. And design implications. So that is why engineering comes into picture. Corrosion resistance material, redundant system in architecture, strict material selection and welding standards plays a very important role when we design the systems. And of course, we can also do condition-based monitoring, reliability monitoring, and so on. Thereby, this design can be optimized and monitored. And when it comes to the transport of hydrogen and storage, basically we have three different options for storing the hydrogen. One can be in compressed cylinders. Of course, it needs a lot of power to compress a cylinder at a very high temperature, very high pressure, which can actually reduce the overall system efficiency of renewable energy to hydrogen. And liquefied hydrogen, actually, it has a higher volumetric density, but it may have a loss of power because you need to cool it to a very low temperature, which is under cryogenic condition, which may also affect the system efficiency. There are options to store the hydrogen below the ocean, or it can be in the below the land. But that kind of technology is still not readily available, and there can be an uncertainties in storing and leakage of hydrogen below the Earth's surface. So these are some problem with the ocean storage and geological storage. So currently we are looking at pressurized storage, which is compression storage, and transporting using pipeline, which is actually a viable method. And when we want to transfer for a long distance, instead of hydrogen, there can be alternate carriers like ammonia, where ammonia as a fuel. Converting hydrogen, rather than producing hydrogen, ammonia can be produced and can be used to transfer for a long distance. Recently, we did a couple of studies about the feasibility of such technologies for Malaysian ocean, and we found offshore floating solar with the hydrogen production can be used for refueling the small ferries between island and mainland, and which can actually decarbonize the shipping industry. So this is a such study we found, and we could demonstrate that annual floating solar generation of 20 megawatt capacity can generate 33 million kilowatt hour of electricity, and which can actually support continuous hydrogen power production for refueling the ferry for round trip from the mainland to the island. So this was a successful case study to show the feasibility aspects of such systems. Yeah.
Sir, actually we are in short of time.
Almost last slide, sir.
Okay, sir. Okay.
Yeah. This is the last slide. So these are some of our publications related to this topic. And coming to the conclusion aspect, as I said, this system is technically feasible. We need to go for economically promising design. Electrolyzer is very important. We need to choose the right electrolyzer. And hydrogen storage and transport system has to be addressed. These are some fundamental barriers. And this technology is actually a very viable one, because we are converting a unreliable power into a controllable, transportable, and versatile energy carrier, and which can be a cornerstone of future energy system. And country like India and many other countries with vast coastline should explore this kind of concepts and propose an alternate pathway for decarbonization and energy transition of the industry. This is our team, and we look forward to collaborate with any partners across the world. And thank you for giving me this opportunity. If any questions, I'll be happy to answer.
Yes, sir, we have a question from Dr. Piyush.
Okay, it was nice presentations, and my question is related to your design looks good, everything look good, but I don't see the effect of your offshore plant on the organism which is living in the ocean or something. Does it will affect the organism or their system?
Yeah, good question, Dr. Piyush. Actually, of course, any technology, when we try to implement, definitely it is going to have some kind of environmental impact, but the system design should be in such a way that it will have a minimized environmental impact of the marine ecosystem. So there are some studies which shows that the aquatic life and marine life has been enhanced because of the platforms which are in the ocean, because it acts as a breeding place for many other biodiversities. There will be little bit impact on other species, but there are some studies which shows that there can be an active breeding and can act as a aquaculture can also go along with this, and there can be a positive impact on the marine ecosystems, considering these platforms allow a kind of breeding for these aquatic species. But of course, there will be a little bit of impact. I think that's why we need to study this system as a whole. Sustainability assessment of such technologies to be considered whenever we want to propose a new technologies, and we need to ensure that the environment will be kept as minimal as possible, and so that we will have a better utilization of these resources. Thank you.
And one more question regarding the hydrogen storage. If we store the hydrogen, the temperature should be negative or something. I'm not sure what will be the minus temperature, 40 degree or 50 degree minus.
Yeah.
So is there some problem with the
storage? That is for a cryogenic condition. Correct, sir. Correct. So there are two aspects of it. One is compressed hydrogen if you want to use it as a fuel for your vehicle or any other transportation fuel. But if you want to use it as a liquid hydrogen, then we need to cool it under cryogenic conditions, so which may also involves lot of energy requirements, and you need to have a special cryogenic cylinders to keep this hydrogen in a form. So the ocean environment will provide such opportunities because the temperature is not that high compared to the land-based tropical regions, so which may favorable to have cryogenic conditions there. And even in colder climates like Antarctica and other places, Arctic region, liquid hydrogen would be a much more viable solution than the compressed gaseous hydrogen.
Okay, thank you. And one personal question, your PowerPoint looks super, and especially your image. So which software you used for the image?
Yeah. I think only one image alone we took from AI. I think rest of the image or we created ourselves. No.
So which software?
No, it's AI tool. We can use Claude A, Perplexity or other tool, and we can actually generate the AI images as well.
Okay.
With proper prompts. No?
Okay.
With proper prompts.
Yeah. Thank you, Professor.
Okay. Thank you.
So we have one question from
thank you all.
Professor Kalyan Kumar Singh, sir.
Yeah, please, sir.
Thanks for your nice presentation, Professor. It was really very nice. I'm working in the last 22 years in the field of materials. I am now working in IIT Dhanbad. You have told hydrogen embrittlement problem. Okay? I have a solution for this. I will send you a mail.
Yeah. Yes.
If you are interested, because recently we are solving this problem for GAIL, Gas Authority of India. So I have a solution for hydrogen embrittlement. I will send you a mail. If you're interested, we can solve it. Okay?
Yeah, sure, sir. We'll be pleased to have, because we also looking at installing such systems for the ocean infrastructure in Malaysia. So we have these issues. So if you have some solutions, we'll be happy to have those things, sir.
Yeah, because hydrogen embrittlement is nowadays it's a problem with that. But we have some solution. I will send you a mail.
Yeah.
If you're interested, we can solve it.
Okay, sir. Okay, sir. Thank you, sir. Thank you so much. Thank you all.
Thank you so much, sir, for your knowledgeful delivery of your lecture. Thank you so much. Online. So next we have our invited speaker, Dr. Dilshad Ahmed. Dr. Dilshad Ahmed is a researcher, entrepreneur, and academic innovator working at the intersection of smart materials, electroactive polymers, soft robotics, and artificial intelligence enabled research ecosystem. He holds a PhD in mechanical engineering with a specialization in advanced polymeric materials and electromechanical systems for aerospace and soft robotic applications. Dr. Ahmed, as a postdoctoral researcher at the Advanced Research and Innovation Center, Khalifa University, Abu Dhabi, where he conducted advanced research in electroactive polymers, dielectric elastomers, shape memory polymers, and morphing structures. His work focuses on the design, fabrication, and experimental characterization of multifunctional polymer system, including high voltage electromechanical actuation and structural testing for aerospace and robotic applications. Dr. Dilshad has authored and co-authored multiple peer-reviewed publications in high-impact Q1 journals. Dr. Ahmed has actively collaborated with the aerospace and industrial partners, notably with Sanad Aerospace, where he has contributed to the development of soft electroactive polymer-based robotic grippers for aircraft maintenance, repair, and overhaul applications. These efforts reflect his strong commitment to the translational research and industry academia collaboration. In parallel, Dr. Dilshad, with his technical research, is a founder of AI Research and Learning Nexus, a research-driven platform and company which is based in Abu Dhabi, UAE, dedicated to empowering researchers, educators, and professionals through AI-assisted research, writing, publishing, and collaborative learning. Dr. Ahmed is a frequent conference speakers, panelists and research mentors known for his ability to bridge advanced scientific research with emerging technologies. Dr. Dilshad is going to deliver his today's talk on smart technologies in modern industry and future education system. Dr. Dilshad, a platform is yours. You may share your presentation now. You are not audible, Dilshad sir. If you can check your mic, please.
Hello, am I audible?
Yes, sir. Now you are audible.
My screen is visible?
Yes, sir, clearly.
Thank you. This is the complete screen you can see. Okay, thank you. Good morning. Good morning, respected dignitaries, distinguished delegates, colleagues, and dear participants. It is truly an honor and privilege to be here at the first international conference on advanced trends in engineering and emerging technologies, I think. And I would like to express my sincere gratitude to the organizing institutions, IIT Patna, NIT Raipur, and New Government Polytechnic College, Patna. This is a wonderful initiative, and I'm thankful to everyone for creating a vibrant platform that brings together academia, industry, and innovators. I extend my heartfelt thanks to patrons, Professor T.N. Singh, Director IIT Patna, Dr. N.V. Ramana Rao, Director NIT Raipur, and Dr. C.S. Singh, Principal NGB Patna, for their leadership and vision. And my special appreciation to the organizing chair, Professor Karali Patra, my PhD supervisor at IIT Patna, Dr. Rajkumar Sahu, my collaborators also, and Dr. Shambhu Kumar, who is the bridge between me and this conference. And I'm really thankful to him mainly for communicating me and for everyone so passionately. And lastly, to the all organizing secretaries and advisory committee members for their dedicated efforts in making this conference a reality. Now, the theme of my talk today is, I don't want to go very much technical what I'm going, but I want to give some kind of vision today through my talk. And the theme of my talk is smart technologies in modern industry and future education systems. It directly resonates with the core vision of this conference. That means advancing engineering through artificial intelligence and emerging technologies. Today, we know that AI integrated robotics, automation, and 3D printing are no longer optional innovations. They are the driving force reshaping Industry 4, redefining manufacturing and transforming how we teach, learn, and prepare future engineers. This technology is a bridge theory with practices, accelerate innovation, enhance productivity, and demand a new, smarter education ecosystem aligned with industrial needs. In this keynote, actually, I will discuss how the convergence of AI, artificial intelligence, with robotics, automation, and this additive manufacturing, all three, is creating intelligent industries, and why education systems must evolve rapidly to stay relevant, agile, and future-ready. We begin by framing this central relationship that education and it drives all economic and social progress. The connection between education and industry is very important. These two forces are the twin engineers of human development, constantly adapting to one another. And we are going to trace this history from the first industrial revolution to the human-centered future we are now building now. And our focus is on how the demands of the workplace have always shaped the structure of the classroom. Understanding this historical arc is critical for anticipating the skills required for the next decade. And we must recognize that the evolution of work directly dictates the evolution of learning. So let's start at the beginning with the first great shift in human productivity. Well, what is that? Our journey starts with the first industrial revolution, a time defined by steam, muscle, and basic literacy. Industry 1 was characterized by mechanization, where water and steam power were replacing human and animal muscles. Work was simple, repetitive, and physically demanding. Education 1 was equally rigid and was serving a very narrow purpose. It focused only on the basic literacy and numeracy, skills necessary for following simple instructions and keeping ledgers. The classroom was simply a simple structure that is designed to produce compliant workers who could endure long hours. And this era established a pattern. The factories determined the school curriculum, because at that time school curriculum was affected by all these initial first revolution. But this system was about to be scaled dramatically. Following the steam age, we entered industry 2, where the focus shifted to scaling up production through electricity and the assembly line. And this was the age of mass production and the strict division of labor. Education 2 mirrored this factory model perfectly. We introduced standardized textbooks, standardized exams, and the one-size-fits curriculum for all. The goal was efficiency, to produce millions of workers who were interchangeable and predictable. And while this system delivered unprecedented scale and economic growth, it came at a cost. And what is that cost? It actively suppressed creativity and individual expression in favor of compliance. And this rigid structure would eventually be challenged by the arrival of a new technology. The third great shift, Industry 3, was ushered in by the computer, bringing automation and the internet, two very important things. Automation began to replace routine human tasks, fundamentally changing the nature of office and factory work. And Education 3 responded by integrating technology into the classroom. We saw the introduction of computers, digital presentation, and the internet as a research tool. Students were no longer just memorizing facts, they were learning to search for and process information. And this digital shift broke the history, or you can say the monopoly of the textbook, and opened the door to a world of information beyond the classroom walls. But the next revolution would embed intelligence directly into the system. And we are now fully immersed in Industry 4, the smart revolution, where intelligence is moving directly into the system. This era is defined by cyber-physical system, the Internet of Things, we call IoT, and the pervasive use of big data. Machines now communicate with each other, optimizing process without human intelligence or intervention. And this Education 4 is the beginning to adopt by leveraging these same technologies. We are seeing the rise of personalized learning, AI-driven tools, and virtual labs that allow students to learn by doing. So these are the key takeaways here. That is very profound. Like, intelligence is no longer solely a human attribute. It is embedded in the system and machines that surrounds us. And this shift demands a completely new approach to how and where we learn. Therefore, moving to the next slide here, we have established that intelligence is moving into the system. And now we must address how we educate the next generation within that system. The future classroom is defined by flexibility, moving learning beyond the fixed time and place of the traditional models. And this shift means learning is becoming personalized. It is driven by AI tutors and virtual labs that adapt to the students' pace and needs. And the core focus moves to project-based learning, ensuring students acquire future-ready skills through real-world applications like the industry, the things which is happening in the industry. And crucially, the teacher's role transforms from a lecturer delivering content to a monitor, guiding students, and become a mentor through complex, ambiguous kind of problems. This flexible model is the necessary foundation for the next major shift, prioritizing demonstrable skills over formal credentials. Now we are starting with the core question. Why do these three technologies, which the focus of today's talk is that robotics, automation, and 3D printing, matter so much right now? The true power lies in their synergy, which is what drives the new industrial revolution. Robotics provides the physical capability, the arms and hands of the smart factory, executing tasks with superhuman precision and speed. Automation, on the other hand, is, we can say, the nervous system, ensuring processes are controlled, optimized, and run with minimal human intervention, and often leading to lights out manufacturing. And 3D printing, exactly the additive manufacturing which you're calling, is the game changer for production, offering unprecedented design, freedom, and enabling rapid iteration. This convergence actually unlocks massive value. It allows for mass customization, producing unique items of the cost of mass production. It builds supply chain resilience by enabling localized, on-demand manufacturing. Ultimately, this synergy delivers a massive leap in productivity and opens, you can say, the new avenues for sustainable productions methods, and the foundation is critical as we move to define the smart factory. Therefore, while Industry 4 is still being implemented, the conversation has already shifted to Industry 5, which represents a philosophical evolution, we can say that. And the Industry 4 was primarily focused on efficiency and optimization, how fast and how cheaply can we produce something. So Industry 5 retains those gains, but adds these critical dimensions like human centricity, resilience, sustainability kind of thing. And the most visible change is the emphasis on human-machine collaboration, driving the rise of the cobot or collaborative robots. We can say that it is on rise nowadays, and instead of robots replacing humans, they augment human creativity and problem-solving skills. Second, Industry 5 leverages flexibility to move beyond mass customization to true individual personalization. Finally, and most critically, is the focus on sustainability and green manufacturing kind of thing. Industry 5 recognizes that efficiency cannot come at the cost of the planet. This shift ensures that the future of industry is not just productive, but also responsible and resilient. Now let's drill down into the physical components, starting with the basics of robotics. So let's move to the physical layer of the smart factory robotics. To understand how AI enhances robots, we must first understand their basic anatomy. Our robot is essentially a sophisticated machine built on three core components. We know that. First, the manipulator, which is the physical structure, the arm, the joints, and the effectors. Yes.
Sir, sorry for the intervention. Actually, we are running short of time, so you could wrap up briefly.
20 minutes, or in how much time I have left?
You have already taken 20 minutes, so we can.
Oh, I have already taken.
Sir.
Okay. Okay. Then I'm wrapping in 2 minutes. Okay.
Sure.
Okay. Okay, then let's move to the final slides. What we are doing here, okay. Yeah. So therefore, to teach this, this robotics 3D printing and this integration, to teach these advanced concepts effectively, we don't need $1 million industrial setups. We need a smart, low-cost, high-impact labs, and the key is integration. For robotics, we can use affordable 6-axis arms like Dobot running and open source softwares like ROS, powered by Raspberry Pi, JSM Nano, etc. like that. So we have reached the end of our session with this because we don't have much time. And I hope I have demonstrated the future of, it has been a genuine privilege to share this vision and these practical strategies with you today. And we have covered the imperative for change, the core technologies driving the future of manufacturing, And for that, actually, I have started a company here in Abu Dhabi that is called Artificial Intelligence Research and Learning Nexus in Abu Dhabi. We have done 7 AI physical meetups, 30 AI podcasts, 7,000 YouTube subscribers, and we are bridging the gap between the industry and university here in especially in Abu Dhabi and all over the world. If you want to connect with me, these are my QR code, and we can connect with that. If you have any questions, you can ask.
Okay, Dr. Dilsad, this is Piyush. I have a question. So when you think this AI ML will replace the woman? Hello. This is Piyush. So when you when you think that the AI
Am I
ML
audible?
yeah. Hello.
Yes, please ask your question.
When you think that the AI ML will replace the woman from the workplace, is it possible?
Yes. Please ask. Yes. Pardon?
Sir, I'm asking you when you think that AI ML will replace the woman from the workspace. Is it possible or is it not? Audible? So can you listen me?
Yes. No. I am not telling that it will replace, but what I am telling that AI and ML will not replace people entirely. They will replace tasks. Yeah. AI and ML. Yes.
Your sound is
AI and ML will not replace people entirely. They will replace tasks, not humans. Like repetitive rule-based and low-skill tasks are more likely to be automated. New roles are being created. Yeah, AI works best as a collaborative tool, enhancing human productivity rather than eliminating it. In industries like manufacturing, robotics, and automation, AI supports humans by improving safety, efficiency, and precision. It will not replace completely. The real risk is not AI itself, but lack of upskilling and reskilling. Like education system must evolve to prepare people for AI augmented jobs. Not like AI is not replacing completely, not outdated roles we are talking about. The history shows that every major technology shift creates more advanced and meaningful jobs over time. It is not replacing, it will also create more jobs.
Yeah. Okay, and the second one is regarding the project-based learning. So for the project-based learning, when you think will be the good time to incorporate project in the class, like from class 10, from class 12, or in the graduate, or from nursery?
Okay. Hello, you are not audible.
Okay, so my next question is regarding the project-based learning. So we are using project-based learning in the US, like in the graduate level or undergraduate level. So I'm asking, what will be the time to include this project-based learning in the class, like from 10 or from 12 or from undergraduate or from graduate, or it can start from early, like from 1 to.
No, Dr. Piyush, it's a very good question. Actually, project-based learning can be introduced from nursery level through play-based, curiosity-driven activities. Like at earlier stages, creativity, communication, teamwork, and problem-solving can be implemented. This project-based learning can be implemented from the nursery itself. In primary and secondary education, actually, this creativity and can say it's PBL that connects theory and real-life problems applications, making learning meaningful. And if you talk about at the undergraduate level, This is called like this can align the students with the industry problems, research challenges, and innovation. And in engineering and technology, we can say that AI, robotics, and automation and design thinking. These things can be implemented as a project-based learning.
Okay,
And
thank you.
countries like, if you're talking about the countries like the US, they have successfully adopted these technologies and increasing the education levels.
Yeah, they are. Okay, thank you, sir.
Thank you.
एक यहाँ से देना
लाइव हो रहे हैं सर
फिर वहाँ पर क्या लग रहा है, हम लोग सामने बैठ कर नहीं देख रहे हैं, लोग लाइव में देख रहे हैं, लाइव में दिखता लोग देख रहे हैं, 3 लोग, एक वो एसपीटी, एक कोई और, एक वो भी दिख रहा है, फार्मर की चल रहा है कि नहीं, ये मेन स्पीकर होता है, अभी फिर 2 बाकी है, एक एसपीटी होता है, बंद नहीं कर सकते क्या? एक चलते हैं नहीं, यहाँ से बंद कर सकते हैं, यहाँ से बंद करके वीडियो से स्टॉप हो जाएगा। साढ़े 5-4 बजे 6 बजे नहीं है यूट्यूब पे बन नहीं रिप्लाई दे लिख दो ना सिर्फ एक दिखाता है
वीडियो एडिटिंग ना, हाँ देखने कौन वो कर रहा है बेचारा बैठ के।
जो अभी ऑनलाइन रखो उधर है ना कनेक्ट हो जाएंगे ना तब फिर ऑन
बाबू खाना खत्म तो काम करेगा जाके चलो भाई अरे नहीं रिकॉर्डिंग लाइव में वो चल रहा है अरे कौन फ्री ऑन कर दिया हम स्क्रीन शेयर कर रहे थे कौन इसको ऑन कर दिया बड़ा जब आदमी हम इसलिए स्क्रीन से ऑन कर दिया हो गया हम इसलिए स्क्रीन से ऑन कर दी गई थी और तरह मिल जाएगा बोले फोटो लिया था ना एक फोटो क्लिक कर रही थी अरे उन्हीं को दिया था आपने देखिए तरह क्लिक करेंगे तो कान में आ रहा है तेरे खाते वाला कौन सा QIP है ना अगर वो वाला नहीं चल पाता है ये वाला उसमें हो जाएगा अभी दे ठीक है खा लो तुम यहीं पर रहोगे ना ठीक है अरे उसको बोलो लेकिन एक बात बोल रहा रिज्यूम पे क्लिक करो रिज्यूम ऊपर सबसे ऊपर
अब इतना लेट क्यों है ना
आएंगे तो मैं करेगा
मिला नहीं
स्ट्रीमिंग कौन करेगा
नहीं तो जाकर लड़ना होता है खुद को खाना भी होता है
हां लड़े थे तभी नहीं है नहीं भी भाई तुम्हारा नहीं देखी है
मेरे को आगे से अच्छा लगता है जब बोल रहे हैं
आप लोग ले लिए
हम नहीं खाएंगे खाना ना तो हम नहीं खाना बोलते हैं
आधे बोले हैं ये तो बोले नहीं अच्छा से बोले हम तो यही ना बोले
बना रहा था
लड़कियां मुंह नहीं बनाती हैं
तुम लड़की है लड़की हो आई एम कंसीडरिंग यू एज अ गर्ल
डिफाइन किया हमने एक तरह से
अबे अभी हमको बोले कि नहीं ये बात करने का, ये तो मिमिक्री होता है, इसमें मिमिक्री बोलते हैं।
तू क्या बोला लड़के लोग
यहाँ बहुत ज्यादा लग रहा है, छोड़ो खाना मिलेगा नहीं तो बोलिए खराब क्या है, खाना मिलेगा नहीं लीजिए और बोल मैं बोल खाना मुझे ऐसा
प्लास्टिक वाला हम लोग तो सैंडविच नहीं मिला करके
फेवरेट में कर रही है।
ओ मैन दो गर्ल्स अगर एक दोनों खाना के लिए हमको
भगवान हमें क्या आसान है,
सर भी बोले
ए बंद करो जी। क्या हुआ
कहां पे करते तुम बोल
सच्ची पागल है क्या यार, मिलेगा कैसे खाना अरे समझ रहे हैं प्रियांशु जी, अब क्या बोल रहे अब ये
गुड सीन वो सो रहे हैं सो रहे हैं जब भी आपको कॉल किया ये बोल रहा था क्या एक काम करो खाना em lại về đi biết này về là kita tuh sering nanya bang kita mas
कैमरा पूरा मतलब रूम में कवर हाँ गूगल में हाँ मीट से कर दे इसको पता नहीं जीपीओ से भी होगा कौन सेम मतलब फारूक सर से एक बार बात कर लीजिए बोले हैं गूगल मीट से ना ठीक है बात काम फारूक सर से कॉन्फ्रेंस के लिए पता है जीपीओ से देंगे कॉन्फ्रेंस हम ये सब जीपीओ खुलवाएं ठीक है हम दो सवाल पे बोलिए हम कर देंगे फारूक सर से बात कीजिए ठीक है कर दें तो करते बात हेलो स्लाइड्स में पैटर्न लैपटॉप नहीं है क्या नहीं हम नहीं कर हाँ सर इसको सर मिक्स कर दे ठीक है सर इसको लीव कर दिए मिक्स कर देते हैं ओके सर 4 6 8 4 6 4
स्टॉप रिकॉर्डिंग में ठीक है, वो तो सब हो गया है ना अभी के लिए। लेट्स फाइल स्टार्ट करते हैं। मीट रुकिए, मीट भेज दी और इसका यूआरएल है ना हमको भेज देना। मान लो कि कोई बीच में आता है ज्वाइन वाइन करने, और यही रखना है यूआरएल, फिर चेंज मत करना, ठीक ना। इसमें तो पर्सनल रहता है, बार बार यही लिंक से कनेक्ट करोगे कनेक्ट हो जाएगा, वो अपने पास भी रख लेना स्टैंड। ठीक है, और बाकी वो एक्सटेंशन वाला जो था कर लोगे। कौन सा? जैसे मिररिंग जिससे, ठीक है, सब चीज़ हो जाएगा। चलो नेट सही नहीं चल रहा है, ये ऊपर ठंडा वाला ना, ये वैसे नहीं ठंडा वाला हम लोग लॉगिन किया है, ठंडा वाला से चल रहा था सुबह से। हाँ सुबह से चल रहा, ठीक है। लेकिन हाँ इसको कॉपी करके हमको भेज देना। नहीं कल ही चलो 3-4 घंटा ऐसे नहीं होता। ठीक है, हाँ नहीं वो ऑनलाइन नहीं यहाँ पे दे रहा है ना, आपका सब प्रेजेंटेशन होगा वो उसके लिए मान लीजिए कोई रिव्यूअर रहेगा आपको ऑफलाइन है, आपका सब चीज
आप लोग ऑनलाइन में थे लेकिन आप लोग प्रेजेंट कर रहे हैं ऑफलाइन, आप लोग ऑफलाइन में प्रेजेंट होगा, ऑनलाइन नहीं है चीज़। जैसे ऑनलाइन वाले चीज़ दूसरे रूम में चलेगा, तो यहाँ के जैसे और जुड़ के देखना चाहेंगे या कुछ होगा जो शेयर करना हो उसके लिए।
हो गया यहाँ माइक है, माइक के लिए हो गया ना, हो गया अच्छा। हाँ सर उसको देख लो, मिररिंग देख लो, ठीक है।
हाँ नहीं लो, ठीक आ रहा था, देखे थे कैमरा ना सही आ रहा है, वो तो दिख रहा है वहाँ पे। एक बार खोलो,
हाँ ठीक है। मिररिंग है,
नहीं मिररिंग, हाँ मिररिंग है जी, वो करो एक्सटेंशन करो, एक्सटेंशन डाउनलोड करो,
डाउनलोड है, खाली ऑन करो।
मिरर मोड फॉर मिरर वीडियो क्लिक करिए ना उसको। दोनों भेज देना,
दोनों भेज दिए,
ठीक है,
दोनों रेडी की पोजीशन है। ये वाला जो प्रोग्रेस नॉर्मल वाला है वो चल रहा है, बस हो गया मेरी। ये यहाँ वाला ऑफलाइन शुरू करते हैं ना,
यहाँ वाला भी हो गया कनेक्ट, ये
कनेक्ट हो गया, ऑफलाइन
रिकॉर्डिंग स्टार्ट कर दूँगी
अभी लाइव थी।
हाँ लाइव, ये रिकॉर्डिंग यहाँ स्टार्ट कर दो, ठीक है। प्रेजेंटर जब प्रेजेंट करेगा तो कैमरा उसके तरफ और ये सब चीज़ है ना, ठीक।
लिंक से शेयर कर दो। हाँ शेयर क्या 045 रेडी है ना प्रेजेंटेशन। पहले उनका करना है, यहाँ से लास्ट तक हाँ बात कर मेरा इसमें भी हाँ हाँ जाना है मेरा हाँ तो मैंने बोलो, हाँ बोलो क्योंकि मेरा वो तभी ठीक है, नहीं चलेगा नहीं गेटअप की रखो पास है, ठीक है स्टार्ट हो गया सब कुछ बस को। हाँ 7 बजे तो मैं ही मीटिंग ज्वाइन करके मैं ही स्क्रीनशॉट करूंगा, ठीक। आप मीटिंग ज्वाइन कर लीजिए पहले, ठीक है मीटिंग ज्वाइन कर लीजिए एंड देन आप अपने यहाँ से कर लीजिए।
आप यहाँ रख लीजिए, लैपटॉप वहीं से कर लीजिए। श्योर सर। पीपीटी है सर इसमें? मैं तो एक्चुअली कुछ और भी लिखा हूँ, तो अगर पॉसिबल हो तो मीटिंग के लिए लिंक है उसका जी मिनट जी मिनट सेव कर दो सर। कट कर दीजिए बैकग्राउंड। कैमरा का फोटो बनाना बहुत बाद में देखना ही है। इस पहले ओके ना मेरा पानी चाहता है मेरा पानी हमें को देगा क्लास खत्म कर देते याद है ये सब इसको हम कैसे घंटा में चला जैसे कल 3-4 घंटे चला 4 घंटा कंटिन्यू 4 घंटा लिमिट लगा कर रख लेता था एक घंटा लिमिट लगा तो लिमिट नहीं लगता करो ऐसे करो
Are you ready?
Good afternoon, you all, in this post-lunch session. Now we have the paper presentation of a scholar from Dehradun. Track ID is AI045, Nishantu Tak. Kindly come forward and be ready with your presentation.
Okay.
Hello. Okay. So I'm Nitanshu Thak and I'm a third year BTech CSE student from UPS Dehradun, and I'm here to present my paper on the topic of it is more of self-detection and ML-driven threat detection and self-healing in cloud. So it is majorly a software product. And that's why I wanted to share a few more things along with the PPT. Okay, so this comes under the DevSecOps ideology. What is DevSecOps? First of all, we need to understand DevOps. DevOps is it is majorly used in the companies, like for example, you have a product on the live website, like for example Google, okay, and you want to update it and you want to add some updates or make some changes. Like on Instagram, we especially as Gen Z use Instagram a lot, and on Instagram we see that there are regular updates, like a button is here, next date is here, and randomly. So to continuously integrate and continuously deploy these changes in the cloud, in the production server or the application which is live for the users, we use DevOps. And for sec means security. Here, security doesn't just mean that you have to secure the cloud or prevent cloud penetration. No. In this, what we need to do is, we need to understand what the errors are, we need to understand what the problems are underlying the system, and then we have to understand that if we can really understand these problems and fix them based on our existing knowledge. There must not be zero-day attacks. If they are, we need to understand them first, and then we can solve them. But it is kind of an anomaly, I guess, because, for example, you are an engineer, and then you come across a zero-day attack one day, and your company's production server is down. You are not able to get it back fixed, or you are not able to fix the errors or revert the changes or the problems. Okay, you're not able to do this. But in my product, what I did is, it is Helios. Okay, I mean, this is the GitHub repo, and in this GitHub repo, first of all, I don't want to just go along with the PPT and theory, because this product does not have any theory, mathematical solutions or anything. This is more about the implementation, this is more about the architecture, and this is more about the operational, operational existence of the website. Okay, it helps in the security, that's the thing. So, first of all, as we can see, the Helios models. What they are basically, first of all, they are Jupyter documents. We load them in the Google Colab, and then we train them and to get some PKL files. And for this product, what I did was, for this project, I have 5 models. It is also an open source project, okay? So if you feel like I want to add this security feature, or I want to secure it this way, you are most welcome to do that. For now, I have 5 models. What these 5 models do is, they are on multiple things, okay? First of all, let's go with CPU utilization. Imagine a day, you are just going along with your work in the company, and suddenly there is an anomaly, there is an error. And with that, what is going on is the CPU utilization or the server utilization for your application or your website. It's surging rapidly with no explanations. This is an issue. This will bring your application down. This will get your production server loosened. And this won't be working anywhere good, because once the CPU utilization increases, it is not just like your app will crash. This is a very basic thing. The major thing in cloud which will happen is your utilization will increase. That's why the load balancers in the backend of the servers, virtual servers, they'll trigger and they'll launch more instances, costing you more. And believe me, they are in dollars, they are a lot. So what these models do is, first of all, we are talking about CPU. This ML model is not like the general ML models. It is more like a model trained on the underlying information it retrieves from AWS itself. So in AWS, if you guys have used it, there's a thing named AWS CloudWatch. Using CloudWatch, what we can do is, we can trigger CloudWatch, and in that we can set up a graph for CPU utilization. The model will automatically fetch the utilization status, and that status will actually need something to propagate for the user or for the developer. So for that, we have one thing. As you can see, the app.py. What it actually is, it is a Flask app. Flask app, if you know, it is a very, what we can say, a lightweight app or a micro app for web services or web frameworks, and it is deployed on EC2 server. On EC2, we can trigger this. It is very micro. It is not like a very high-end production-ready thing, but what it will do is, it will trigger, and it will first of all fetch what the anomaly is, and it will trigger slept model from behind that this is the problem, you gotta wake up, and then the model wakes up, solves the problem, and returns the triggers to the user. How? If the spikes are going upper in the graph, it will send an SNS, simple notification service. It is also a AWS service, and it will directly go in a mail. I'll show you the demo video right now. So if you have a CPU utilization of your server which is going up, the spike will go up in the graph, and you will directly get a mail that this is the problem. You gotta fix it. Okay, so this was for CPU. Similarly, we have 4 more. One is for networks. First of all, I want to talk about other one, the storage one. Just like CPU, your storage might surge up too. Your storage might have issues, or there might be race conditions or something. To prevent them, there's this model which tells you about these spikings in the storage services. Both of these models use isolation forest algorithm, and next one, we go with networks, because network is one of the most sensitive thing, in my opinion. Using it, a hacker can easily gain access to your application or your server, and to protect that, we need a network fixation in this, and it uses a k-means algorithm. So it just clusters all the anomalies together and protects our system from them. Next is login attempt, which is very basic and very obvious that if there are multiple login attempts with negative timestamps, and in my opinion that I mean there are login attempts and those are failures, and those are not from the secured pipeline, or those are not from the secured connection, then mark a warning that will be triggered by that. Similarly, what these models are, it is not like just random, this attacks that and this gives you that. No. For every application, you need a security. Without security, your application will definitely fail, because nowadays, anyone can build a software and build something and deploy. You guys might have heard about vibe coding, right? Yeah. So you might have heard about vibe coding. What it essentially is that people just use AI tools and just create their websites, and that's all. But the problem arises. Okay. Sure. So the problem arises, anyone can build a product and deploy it on the website. Like we have Vercel, Netlify, Streamlit, and multiple applications for that. But the problem comes is security. If there is no security, anything can go very downhill. Someone might launder money, someone might gain access to your private information, and etc. So that's why security is very essential. This was the main key highlight of this project, and it was essentially, honestly, my teacher said that you guys gotta make a project and the assignment, but I had some different ideas, and I made this. It is not for just an assignment. It was for understanding an issue which recently happens. Like you guys might have heard about the cloud services went down, and there were many issues. Okay, so for them, we always need a secure pipeline and security to base that up. There's also one thing which is self-healing, and I won't go into much detail because it is in the paper, but the thing is, I also made one more project. I won't go into much detail, but what it does is, it uses five major things, typically 6, AWS EKS, Kubernetes, Docker, Prometheus, and Grafana. What it does is, it is literally the self-healing. Typically, companies nowadays don't use like basic virtual servers and all. it was a very old thing. It was introduced by IBM decades ago. Nowadays, companies use containers, and those are maintained by Kubernetes. Now, someday you might just wake up and know that your Kubernetes pod failed. It went down or whatever. It isn't live actually. So what this project will do, it is a site reliability system. So it will just redeploy a Kubernetes pod. If it goes down or if any issues occur, it will just redeploy it, and based on that, your site won't be down, or your production site won't be in no business time. Now, I want to show you one thing. Yeah, first of all, before it starts, I want to tell one more thing. This is not a new thing. There are many reliability softwares available, but what this project does is, you might all have heard a meme like चोरी के बाद पुलिस आई थी और उसके बाद कोई मतलब नहीं रहा. ये शायद मैंने कहाँ सुना था, मेरे को याद नहीं है. बट सिमिलरली आजकल के whatever the projects we have, what they do is they will mitigate the site reliability functions after the site is down, which is a very significant issue. So that comes under a very major issue, because once the site is down, then it will trigger the NPTR responses, and then it will fix it. That's an issue. There's also one more issue, zero-day attacks, like I said you. So in this project does not wait till the site is down or the production server is down for that. It triggers the algorithms right while any changes are made in the cloud environment. Whenever it feels any change, it will trigger the algorithm, and based on that, it will fix it. And for the zero-day attacks, it does not only rely on the signature data lines, but it also focuses much more on its algorithms. So it is not like it is untrained for anything. In fact, for zero-day attacks means you might have, for example, trained yourself for 10 type of attacks in cybersecurity, and then on the other day there's an 11th attack which is on your website. You don't know anything about it, you don't even know the name of it, but for that, whatever the current present site reliability softwares are, they focus on those 10 problems and fix them. This project has algorithms which actively work for all the zero-day attacks either. So they don't need actually any different algorithms or something. They have already built-in algorithms which don't just follow these 5 things, they follow everything other related to them, and for them it is not just a second. Okay, sir. Okay, sir. So as I was saying, it also works for the zero-day attacks either. Now for the final, I want to show you the demo video. Bear with me the quality of it. These are the models actually. These are the models which I said will train on Helios. The Helios models will train on Google Colab. We'll get the 5 models. We'll load them into S3. S3 is an object storage bucket. We'll create a bucket and we'll add our models in them.
Move to your conclusion part directly.
Yeah,
please finish it off.
models will be in the S3 bucket. Bucket will be loaded in the EC2 instance, as you can see above there. Then on the instance, the Flask API, this is the Flask API code. It uses these models to check, first of all, fetch the anomalies and check which model relies with them and fixes them. And this will go to CloudWatch, where the graph will increase, and this will trigger. These will be the graph, and this will give us mails, multiple mails actually. As you can see, there are 41. Yeah, but yeah, you got the point. So this was the major thing about this project. Thank you, sir.
Anyone have questions?
Okay, thank you. Thank you so much. Next, we have paper ID AMN018 in the track Advanced Materials and Nanotechnology.
Good morning, Professor and my dear friends. So my name is Hemant Priyadarshi, a research scholar from IIT ISM Dhanbad, and today I am going to present my work titled Transverse Fatigue Performance of Multi-Wall Carbon Nanotube Reinforced Glass Fiber Epoxy Composite Laminate. This work has been carried out in Polymer Composite Lab, mechanical testing and damage analysis under the supervision of Professor Kalyan Kumar Singh. Next. So FRP composite consists of the fiber and the matrix. Here the fiber is act as a primary load bearing member, and matrix is used to transfer the load to the fiber and to protect the fiber from the environment. And the combination of these at a microscopic level gives the FRP composite. So these are the various advantages of FRP composite, like reduced weight, high strength, high stiffness, non-corrosive in nature, and high fatigue resistance. Because of these properties, these are the various applications in aerospace, automobile, marine, or defense, etc. So GFRP composite laminate fabrication process, these are the flow diagram of how to disperse MWCNT in epoxy resin and how to make from lamina to laminate. So here the first step is the MWCNT and acetone mixing by the magnetic stir, followed by the sonification of MWCNT and acetone. After that, the pouring of MWCNT acetone in a epoxy. Then the sonification mixture get a uniform dispersion for 15 minutes. Then to evaporate the extra acetone in between the matrix, use oven. After that, the mixing of hardener to a epoxy resin at a ratio of 10:1. So these are the desired stacking sequence, symmetric laminate of 090 plus minus 45 plus minus 45 090 symmetric laminate, followed by the hand layup for the laminate fabrication, application of matrix material on the fiber sheet through a brushing method, rolling up to ensure the uniform distribution of epoxy into the fiber, placing the laminate in a vacuum bag arrangement. After that, the placing the vacuum bag arrangement into a autoclave chamber. So these are the process from lamina to laminate. Next. So our test is fatigue test setup. The figure 1 shows the fatigue test specimen with the ASTM standard D7774, and the dimension of the glass fiber specimen is 66 into 14 into 3.2 mm3. And the figure 3 shows the experimental setup for the transverse fatigue test. And these are the parameter I have taken. Like for the flexural test, cross-head speed is 1 mm per minute, and the dimension is 66 into 14 into 3.2 mm3. For the fatigue test, stress control frequency is 3 Hz, and the stress level is 50% to 90% of ultimate flexural strength, and the stress ratio is 0.1, and dimension is same as the flexural stress, flexural test. Next. So these are the results. This graph illustrates the typical load versus displacement curve for the GFRP and GFRP embedded with the MWCNT. Here is the neat GFRP curve, and this one is the GFRP with MWCNT reinforcement. And this figure, this table shows the result of neat GFRP. The maximum load is 741, and for the 1% of MWCNT, the maximum load is 864 megapascal. So the symmetric laminate strategically position 090 plies for both the outer side, boosting the flexural stiffness. So here you can see the load is maximum in case of the 1% of MWCNT as compared to the neat GFRP. Next. So this graph shows the typical maximum flexural stress versus the number of cycle failure for the neat and MWCNT GFRP. The fatigue result demonstrate that the each type of laminate for a given fatigue stress 90%, 80%, 70%, 60% and 50%, the ultimate flexural stress, the life cycle of 1% by weight laminate is considerably higher as compared to the neat GFRP. Next. So this is the in situ damage analysis of fiber matrix interface of GFRP laminate. Here you can see the failure like the fiber pull out, fiber breakage, matrix cracking and delamination for the neat GFRP and the MWCNT embedded GFRP. Next. So the conclusion, the flexural results show the significant improvement in the mechanical performance of MWCNT. The maximum load increases from 741 megapascal for neat GFRP and 864 for the 1% MWCNT. The flexural, the mid-span displacement increases from 4.07 mm to 4.59 mm, reflecting improved energy absorption and damage tolerance. The fatigue test further shows longer fatigue life for the MWCNT across all the states level from 90% to 50% to 90% of ultimate flexural strength, attribute to improve the interfacial strength and cracking characteristic mechanism. So the overall 1% MWCNT integration enhance both the static flexural property and the fatigue durability. Next. So these are the references. Thank you.
You have any question? Sir. So what is the glass transition temperature of epoxy? I would say.
GT. So I don't have
epoxy you have used.
Epoxy Araldite LY556.
What is that glass transition temperature?
I actually don't have that.
Acetone purification temperature. सर एक्चुअली जो है आप कितना टेम्परेचर तक ये गर्म करते हैं?
क्या ये सोनिकेशन उसके लिए तो मैक्सिमम 40 या 50 डिग्री सेंटीग्रेड जाता है मैक्स टू मैक्स. हाँ उसके लिए थर्मोकपल.
But you have not checked that glass transition temperature. Now you have decided that this temperature you are sonicating.
Actually, in the sonication setup, there is a thermocouple. They measure the temperature. From the literature, I have actually
Studied about the glass transition temperature of the toxin.
Actually, I don't hear about it.
So maybe its property will change after glass transition.
Yeah.
And sir, you have done 3.20.
Yeah, flexibility test.
So why you have not done a tensile test?
So actually, I have measured the fatigue performance of compare the fatigue performance of
Layered or single composite?
layered.
Layers.
Yeah.
So it will be different. Tensile strength and the flexible strength.
Yeah, different.
So why you have not performed?
Actually, my focus is to measure the fatigue life of neat GFRP and compare to the MWCNT.
Without tensile strength, you cannot.
So after measuring this fatigue life, where you are going to utilize this fatigue, whatever you have rightly told that you are going to analyze the fatigue life.
So there are so many applications like in leaf spring of the vehicle, four-wheeler.
Can you tell me that which type of fatigue is going to happen?
Leaf spring, cyclic fatigue.
High cyclic or low cyclic?
Every cyclic load is like.
Yeah.
So which type of fatigue is that?
You are doing a high cyclic or low cyclic?
If a fluid is flowing in a pipe, so some load is coming on the surface of that pipe.
Yeah.
That is also a kind of fatigue loading. Can you tell me that which loading is there on the surface of that pipe?
I don't know. Okay.
Okay. Next we have from Advanced Manufacturing and 3D Printing track, paper ID AM3D006.
Good afternoon, sir. I am Mani Thakur from IIT Patna, PhD scholar, under the supervision of Dr. Murshid Imam. My topic is microstructure evolution and tensile properties of CNT reinforced selective laser melted ALSAT NMG processed by friction stir processing. You all are familiar with the 6 series alloys. Aluminium 6 series alloy. Aluminium 6 series alloy is difficult during 3D printing process because it contains only 1% of silicon, due to which flowability during melting is not good as ALSAT NMG material, because in ALSAT NMG silicon percentage is about 10%. So we are increasing the percentage of silicon, due to which flowability of the metal will increase. Next. These are the contents which I am going to discuss in the further slides. Next. Coming to the applications, these are the applications of material, medical applications, aerospace components, automotive parts, electronic parts, defense sectors, and these are the applications that is heat sink components, antenna brackets. These are the applications of ALSAT NMG material. Next. Now coming to the material, as I discussed earlier that silicon is about 10%, aluminum is 88%, and magnesium is 0.78%. These three are the main component. And advantage of this material is that lightweight material, high strength to weight ratio, corrosion resistance is also good, thermal conductivity is also good, and at this silicon 10%, Mg2Si precipitate is formed, due to which strength of that material increases. As we see from the phase diagram, this delta T, solid to liquid to solid transformation temperature is very less, due to which time for grain growth is very less. So we obtain refined grain in this material. Now, in this I have prepared this ALSite NMG material by the help of 3D method, that is selective laser melting. Selective laser melting is a process in which product is formed by selectively melting successive layers of powder by interaction of laser beam. Advantage of this is that complex object can be made, reduce material waste, eliminate the joining process, and dimensional accuracy is good. But disadvantage is that surface finish is bad and residual stresses is in the final product. So for removing that disadvantage, we have to do the post processing, which I have also done. Basic principle is that this is the single track of the laser. When this single track of the laser is over, we get the single layer, and this single layer is overlap vertically, then we get the final product. And please, this is my material. This is the simple diagram which show that during selective layer melting of ALSite NMG, aqueous grain is formed during at the melt pool boundary, and columnar grain is formed in between the melt pool. Because G by R ratio is low at this melt pool, so aqueous grain is formed and columnar grain is formed in between the melt pool. Next. Now these are the post-processing techniques, which we can done after selective laser melting. But I have done frictional stir processing because refined microstructure is obtained by the frictional stir processing. A different SLM defects such as residual stress can also be eliminated. Next. This is the methodology which I have done. First I have select the machine that I have to do the post-processing technique, friction stir processing. Then I have make a ALSite NMG product by selective laser melting process. Then I have selected tool, threaded pin type tool. Then I have selected the reinforcement. That is CNT. Then I selected the process parameters of FSP. Then tensile test, hardness test, and other microstructure test I have done. Next. Now, this is my material made by selective laser melting process, and this is the powder by which that material is formed, and this is the composition which I have done by EDS SEM process. Aluminium is 88.49%, silicon is 9.4%, and magnesium is 0.48%. Next. Now, I have done friction stir processing without reinforcing CNT and with reinforcing CNT by slot assisted method, and I have got the defect free part. This is for CNT and this is for without CNT, and this is my product. This is for CNT and this is without CNT. Next. Now this is a silicon network. This is silicon network formed in SLM product, because during solidification what happened, silicon is insoluble in aluminium. So during solidification, aluminium pushes the silicon to the boundaries. So at the boundaries, silicon network is formed. So in SLM, we see silicon network, and after doing FSP, that silicon network break and form columnar shape. And this is my SEM image of CNT sample, in which we can see that CNT reinforcement is seen uniformly distributed. And I have also done EDS, and carbon percent is 5.63%. Next. Now this is of SLM part. We can see that melt pool at the boundary of the melt pool, aqueous grain can be seen, and in between columnar grain is seen,
And after doing FSP, grain refinement takes place, and in case of CNT, more grain refinement takes place than that of the FSP. This is due to the general peeling, orgonal looping, and due to presence of the carbon nanotube and silicon in a CNT product. And this is the misorientation boundary comparison. In the case of CNT, higher angle grain boundary is maximum than that of other, so more strain can be formed, can be in CNT product. Next. Now this is my TM. This is my SLM product. This is silicon network. Some precipitates can also be seen. Mg2Si precipitates. This is the dark film. These are the precipitates. Mg2Si film precipitates. And this is the shape of Mg2Si precipitate, which is formed in SLM sample. Next. Now this is the time result of CNT sample. We can see the columnar silicon particle, which is broken after the frictionless procedure due to high deformation. And these are the dislocations. These are the dislocations. After FSP, large number of dislocations form, and due to which hormone looping can take place and the strength of the material increases. And we can also find the evidence of the carbon in CNT sample. Next. Now this is the stem areas in which this is the silicon network, and for CNT sample we can also see the broken silicon particles and some evidence of the carbon also. Next. This is the micro hardness test I have done. In the case of CNT, we can see that average micro hardness increases, and this is the XRD, in which we can see that some carbon presence is there. Next. This is the tensile test I have done, in which we can see that UTS increases. UTS increases, and I also compare all these YS, UTS, and uniform elongation. And in the case of CNT sample, all the parameters are increases in comparison with both FSP and SLM sample. Next, I have also done the strengthening mechanism comparison of these three. SLM plus FSP, and CNT. All the strengthening parameters I have compared: Hall patch, dislocation strengthening, hormone looping, solid solution strengthening, due to stacking fault, because in time I found some stacking faults, load transfer strengthening, stress due to thermal mismatch, and I add all these, and I found by calculating, by estimating by the formulas and by the experimental, I found that I have error of 13.5% in SLM sample, 2.9% in FSP sample, and 6.5% in CNT sample. Next. Now, so FSP eliminates porosity, transfer columnar grains, structure of SLM air energy into fine equivexed grains, carbon defined during FSP, further defined grain structure through particle stimulation nucleation and shear-induced dynamic decrystallization, leading to the enhanced mechanical properties, and the tensile test, including yield strength, ultimate strength, uniform elongation, is also improved in the case of CNT sample. And last one is that I have compared all the strengthening mechanism in all the cases, and the calculated experiment, and the small increase in error for SLM, FSP, and CNT sample due to microstructural complexity. Sorry. These are the references.
Can you go to the conclusion slide? Yes. How you are saying that shear-induced dynamic recrystallization has taken place? Can you go to that slide?
Because I have one result also. I am not adding this because 20 slides. I have also do Gauss mapping. I have Gauss mapping, and I compare 0 to 1%, that is nuclear recrystallized grains, 1 to 2%, that is sub.
No, you have not shown those results. That's why I'm asking.
Yes, I have compared. If you say, then I can show it.
And you are saying that after welding, there is no any inhomogeneity.
After processing,
there is homogeneous distribution, right?
Homogeneous distribution of CNT. Yes.
Yes, CNT. How you have cross-checked with that there is a homogeneous distribution?
I have seen I have also shown that SLM sample SLM SEM images. And I have also done EBS at 5 to 6 different places. This is done for 100 nanometer. This is I think 50 nanometer. This you can see this image.
What is the black spots which you are writing?
This is this image this is carbon nano. This is CNT. You can see that this is carbon.
No. I want to see your dispersion for not.
This person.
Uniform dispersion we are talking about, and how you have found the homogeneity of that dispersion.
But this image, I can see.
Have you done 100 nanometer?
No, I have.
You can do.
I have done, but not 100 nanometer. But
because one which usually can't take without 100 nanometer.
Yes.
Okay, thank you. Next we have from the same track, Advanced Manufacturing and 3D, paper ID AM3D007.
Thank you, sir. Good afternoon, all of you. I am Mohammad Parvez Alam, and I am a PhD scholar of IIT Patna, and I am doing PhD under the supervision of Dr. Murshid Imam. And my today topic is the effect of friction stir processing on the tribological and electrochemical behavior of selective laser fabricated Ti6L4BLY. Okay, next. Okay, this is the outline of my presentation. First of all, you see here how SLM product fabricated through the SLM machine. Please start this. Okay, so selective laser melting actually laser the product in which we have a substrate and on which we can spread the powder particles and the laser fall on the powders, selected powder layer, and after that it's melt and fuse the powder particle, and this process repeat until and unless we get the final product. And this actually next. Okay, so why we take this Ti6L4BLY? What is the reason behind this? Actually, it has a lot of application. Okay, and majorly we can see its application like in biomedical sector, aerospace, chemical sector, marine sector, and so on. Actually, it has a lightweight and a high strength to weight ratio, and enhanced biocompatibility, and lots of property of this Ti6L4BLY. That's why we take this material to characterize the for application point of view. Okay, so this is some basic information about the Ti6L4BLY. So this is actually alpha plus beta alloy. Okay, in which 6% medium that has SCP structure, and 4% vanadium that has beta phase, that means BCC structure. Okay, and actually at the room temperature, actually we can understand this phase diagram. So at the room temperature, SCP structure is stable, but if you increase the temperature, then it goes into the beta phase. It means that at 980 degrees centigrade temperature, that is called Douglas temperature. At this temperature, beta phase actually is stable. And this is the triple T diagram. Actually, the microstructure of this LY has so complex. That's why, and it totally depends on the temperature. Like if the temperature is in between 20 to 1.5 degrees centigrade, we can see here minus structure. And then if the temperature is like between 410 to 20 degrees centigrade, that has mixed structure. And if the temperature lies between 520 to 25 to
410 degrees centigrade. Temperature is equal to alpha. There are some parameters involved in this SLM process like H spacing. There are some parameters involved in this SLM process like H spacing, scanning speed, layer thickness, and layer scanning speed, layer thickness, and layer power. These all parameters actually gives the quality of product. Okay, so these are the post technique comparison. Basically, I have used the friction stir processing. So why I use this friction stir processing? So why I use this friction stir processing technique? Because there are processing technique. Because there are some advantage over the given this some advantage over the given this post processing technique like hot isostatic pressing, measures of pinning. Basically, friction stir processing actually defines the grains and enhance uniformity, and also it's reduces the porosity, and also it's refine the grain. That's why we use the porosity, and also it's refine the grain. That's why we use FSP process. This is like a surface treatment technique. So, what is the basic difference between FSW and FSP? Actually, FSP processing is derived from FSW. Okay. In case of FSW, actually we join the two materials, but in this case, we actually process the sample on the surface. That actually enhances the surface quality. Okay. There are some applications of this processing like casting, powder material fabrication, and so on. This is the methodology. Actually, I have taken the TI6 tutorial, which is obtained by the gas optimization technique, and finally we fabricate through the SLM technique. And these are the parameters, and also I have mentioned the FSP parameters. And so basically, I have optimized, and this machine actually we use to characterize the microstructure and mechanical property of the material. Okay, this is the result and discussion. This is our product, which length is 100 millimeter and width is 50 millimeter and thickness is 5 millimeter. And then after that, I have done the FSP on this SLM sample, and we get this type of processing zone. Okay, this is the actually profilometry, in which surface roughness of the product. So before FSP, the surface roughness is more as compared to the after FSP sample, as compared to the after FSP sample. Okay, you can see clearly here, and and after the I have also seen in the figure F and G. We see the figure F and G. We see the tool of before FSP. Before FSP and after FSP. Okay, this is the after FSP. Okay, this is the optical micrograph. In SLM sample, we see clearly here. In SLM sample, we see clearly here lots of pores and voids, and also it's after FSP. After FSP, you can clearly see in FSP zone there is no pores. Okay, because in SLM actually lack of fusion and some regions there are a lot of in FSP case actually the FSP tool is not the material that reduces the porosity. Okay. And I have also checked the porosity level through the automatic principle, and I have found out after the FSP the porosity is removed 3%. In this same image of this is the same image of the SLM sample, in which is clearly see the laminar alpha, that is type of portion, and this is also confirmed through the EBLT color orientation map. Okay, and after FSP we can calculate using. Okay, this is the simply exciting last 2 minutes. This is the 10 results. In SLM sample, we clearly see the dislocation density also. The width of the lamina is wider. Okay. And this is the 10 image of the FSP sample. in which we clearly see this is the basket wave structure in which the grain refinements we can clearly see, and somewhere we can see dislocation triangle. This is due to the dynamic crystallization and dynamic recovery. And the titanium, iridium, and aluminum conform through this SAD pattern. And finally, this is the wear results. We can see after the FSP, the wear resistance is increases as compared to SLM sample. This is the 24 phytometer that confirms in case of SLM sample, the depth of wear tag is more as compared to FSP sample. So this is the electrochemical test that is
go to your conclusion.
Okay, so finally, the conclusion point is FSP removes SLM induced porosity and refine the lambda and basket wave microstructure. And the micro hardness value SLM and FSP sample are 364, and after FSP is increased like 390.47. And corrosion test, so the FSP improves passive film and stability by refining the grains, narrowing alpha prime grains, and reducing the electrochemical difference.
Have you measured it on this side? Porosity,
yeah, I measured through the 20 pins curve, not side measure.
What type of porosity you have? Micro or?
Micro.
Any idea about the size of the micro porosity?
There is one experiment that is called
Have you checked the fatigue performance also?
No, sir.
Then how you are saying that enhancing surface integrity and fatigue?
By literature, sir. Actually, in some literature survey after FSP, fatigue ratio.
And you have shown that in the application that titanium was, right? Can you give any examples where titanium were used there in the ring of the elevator?
Yes, you have shown now. Yes, in the application part.
Yes.
Can you give an example of any company or anywhere?
The company, sir, I have no idea.
No, if the ring will be used, you know, firstly the titanium is.
Yeah.
And if you are using titanium, yeah,
it's a costly.
It's like this slide.
This slide you have shown.
Yes.
With the ring. It's the ring only, na?
Yeah.
Even BMW cannot use it.
So it's a drawback of this environment.
What is the strength of this titanium?
So UTS across 1086 MPa.
And see, particular material cannot be, used in wide range of applications. What you are showing biomedical sector as well as military, you are showing some engine parts. So same type of TI-6A14B is what I feel so that it is very difficult to correlate all the sectors.
Due to some features, that's why
no, that features you are not able to explain. That's why because like this ring, how I have asked you simply.
No. We have got 1086 MPa. UTS, sir. UTS, yes.
No, so what I think that I have suspected on these applications, whatever you are doing.
I was taking from literature survey, na?
Yes, sir.
You have done so many results analysis, right? Can you show me that what type of where you are going to apply these results?
Where you are going to
apply these?
Initially, we see the microstructure. How FSP turns the microstructure of the.
What is the reaction part? to the result part.
Sir, actually, I have also done the tensile test, but not showing the slide. So actually, I have found that after the FSP, without losing the strength, the ductility will increase. Due to the some we can
This setup in our IIT.
Yes, sir.
No, see, usually so many people they have shown that after doing the MSP, the activity is going to increase. So many literatures are there.
Without losing the strength.
Without losing the, so many literatures are there. No, already literatures are there. So what is your contribution in this paper? I'm trying to understand.
What you have done?
Yes, see, I totally agree that you have done so many analyses, you have done so many structure analyses and mechanical, but why? My concern is why.
अभी एक लिंक भेजना है पहले सेम लिंक चल रहा है पुराना वाला लिंक ना
पुराना वाला ही लिंक चल रहा है 4 बजे से
चेंज क्यों कर दे रहे हो भाई 1 आवर से ऑटोमेटिक कट हो गया नहीं उसी लिंक पे चलोगे ना उसी वो लिंक में चलेगा दूसरा लिंक क्यों कर रहे हो लिंक पुराना था उसी पे करो ना चलो आपने को जो शेयर किया वो सिर्फ वाला कहां ज्वाइन कर पाए वही कर दो बाबू कर रहे
Good afternoon to everyone. My name is Asani Singh, pursuing MTech from IIT Patna under the guidance of Professor Karali Patna.
Today I am going to present the topic on autonomous restaurant service robot. Okay, this is my outline of the presentation. First of all, I introduce my topic. Then after problem statement, followed by methodology, then after hardware implementation, so on by, at last I will try to explain conclusion of my project. Yes, what is this robot? This is not unlike AGV, it is not required any predefined path to motion. It automatically avoids obstacle and creates its own path with the help of LiDAR sensor and ultraviolet sensor. These are the problem faced by so many restaurants, like lots of labor shortage, hygienic contactless delivery. This can be reduced by with the help of my project. Next. Yes, market service. If we want to purchase this robot in the market, its minimum cost is 7 lakh, but we will try to make this in less than 2 lakhs. This is my project aim, to make such type of robot which can deliver food at the table and take order from the table and go to the kitchen and take food and deliver to the customer. Okay. Next slide. Okay, this is my methodology. First of all, I want to simulate this on gazebo and RVZ. Then after hardware implementation and software implementation, which is able to give command to the robot for motion. Next slide. This is simulation like gazebo. You can play this video. This is the view of turtle board 2. Like this is the view of turtle board 2, which is not my robot. Yes, but in gazebo it is more clear in comparison to RPZ. All the lines are the permanent obstacle, and these lines shows the local obstacle, which can you can move forward. Next slide. This is hardware implementation of my robot. Like I integrated ROS with Arduino. Means I did coding in ROS, which give command to the Arduino for motion of left motor and right motor. With the help of ROS, get data from the LiDAR, which detect the obstacle from the real-time view and give command to the Arduino for motion of the left motor and right motor. Motor will move or not, it is known by the Arduino with the help of left encoder and right encoder. It is the basically feedback device which is implanted in the motor. This is the calculation of tipping angle, means for which amount of load can carry my robot without toppling. Like 23.5 degree angle will come after the calculation of base radius upon center of mass, center of height radius. This is the maximum angle which can be sustained by this robot without toppling. Next slide. This is the circuit diagram. Like Arduino Uno is connected with the stepper motor, which helps for tray movement, and it is also connected to the motor driver, which runs the both left motor and right motor. And this is Raspberry Pi, which acts as a software. Like if we want to integrate screen, then it will replace. But if we do not want to integrate screen in my robot, then this will help act as a device. Next. This is my software implementation. Like if LiDAR, this is the data published by LiDAR. Like LiDAR continuously publishes data which seen by this LiDAR. And this data will sense by navigation stack. Like if it sense any obstacle, the left motor and right motor can change their direction. This is autumn publisher. Like want to generate map of the area. This continuously publishes the data of that area, and this topic is subscribed by also navigation stack, which can sense and which can generate this type of map. This line shows the permanent obstacle, and by motion of the robot, it is sensed by local obstacle. Like CMD velocity, it is subscribed by teleo velocity, which sense how motor will move. And goal status subscribed by tray controller. If the goal is if the desired place reached by my robot, that this automatically tray will open and anyone can take the desired food. Next. Yeah, this is automated too. First, this shows how robot will move when this is not done. If I not do any type of tuning, if I give command for motion of straight line, the robot will automatically moves due to lots of debugs, like a motor. Suppose motor can get stuck in somehow. This type of motion can done by the robot. But after tuning, sorry, don't play forward. After feedback correction, the robot correct their path like this way. But after adding PID in the correction, this will operate not 100%, but yeah, 99% can straight. Next. This is the map of my robotics lab, which is generated by my LiDAR camera. Okay, you can play this video. This is the map generated by the robot in real time. Like this line shows what is the obstacle which is permanent, and if I put anything in between this, the robot will automatically sense and move towards the obstacle path. Yeah, this is the map generated by the robot, and if I give the command to reach this position for the serving tray, robot will automatically follow the path and go to this way. Robot will automatically follow the path and reach to the goal, and tray will automatically open for taking that item. Next part. This is the map of the robot from where we can give the desired location for the delivery of the food. This is conclusion of my report. Like complete in-house development, avoid obstacle, and core functional is achieved. Next. Thank you.
So, have you created some app so that we can monitor?
Yes, ma'am. This is my future scope of this report. Like we want to create a certain type of screen which can be easily run by anyone for the transmission of the robot and to reach the any location.
And which IoT tool you have used for this?
And ROS, robotic operating system.
It is free or
ROS tool, yes. Yes. And it is free. It is coding language.
Then what about security, data security?
How this is secure. If anyone trying to use the ROS tool, it is secure from the parent company.
Because I know that the link and links is free, which is freely available, and student is also using that type of tool. So some limited clouds are available in that server. Apart from that, if students want to store some data, then they have to purchase it. So that's why I'm asking.
No, this is free of cost, and basically this is not run in Windows software. It is run in Linux software, so it is totally free. How much amount of storage?
What is new in this one? Like I have seen a robot which can clean the house.
Yes.
Like I have in my apartment.
Yes.
Which can clean the house. If you give him the command, it will clean the house.
Yes.
Then what is the new in this one?
Sir, basically that robot is very much expensive. Like only the base of that cleaning robot is comes approximately 2 lakhs to 2.5 lakhs. That robot is present, but only for cleaning, not do much task. Like my robot can do that. If I give command to go and reach and serve this type of item, it will go and open the tray, and that item will be served that way.
Go to the design part. No, in one of the restaurant in
Yes, sir.
They have a robot which can serve the plate.
Yes, sir.
It will go and serve you the plate.
Yes, sir. Yes, sir, it is available in the market, but I am trying to bring it cheaper in from the market.
How much you took? How much the price you took?
Less than 2 lakhs. Less than 2 lakhs.
How much?
Sir, I am not at 2 lakhs. I am not 135.
Okay. Okay.
So how many tray in your play that? Yeah. What is the payload? Sir, payload I have not calculated, but physically I have calculated like 22.5 kg. It can be about so for 23 tippling, I have put the 5 to 10 kg there.
And the maximum speed it can handle?
Sir, it is up to me. Like it is stepper motor. If I replace that motor with the DC motor, it can achieve which type of speed I want.
And have you tested with
Yes.
some elevations like stability of this? Its height is too large,
yes,
and you have used only 2 wheels.
Yes. Yes, sir. No, sir. Actually, I have uses 4 wheels. These 4 wheels are mounted here, but not powered by any motor. It is for only balance.
When you have made this one?
Sir, in my lab, IIT Patna Robotics.
I am working with whom?
Under Professor Karali Patna, sir.
Okay, nice.
Thank
So we have a special guest, Anupam Sinha sir, Technical Officer, CPET, Hajipur. Sir is working in the area of waste management. I would like him to come forward, and I would invite R.K. Sahu sir to kindly felicitate him with solemn moment. Okay, Sambu sir, please come forward.
एक कल्याण सकता है नहीं वो तो दिक्कत बिल्कुल करने के लिए बैठे हैं कल्याण सकता है हाँ एक ठीक है चला जाएगा तो हैं वो करेंगे हार्ड कॉपी भी चाहिए तो बाद में सेलेक्ट कर सकते हैं समझ सकते कलेक्ट कर सकते हैं तो नहीं
Hello, sir. Hello, sir. Hello, sir. Yes, sir.
हाँ हुआ ऑन करो अनम्यूट
Hello.
हेलो
Yes, sir.
पेपर
Hello.
ID AMN 003 are you available?
Yes, sir. Yes, sir.
Okay, so you may start. Kindly share your slides and start your presentation. You have 10 minutes, 7 minutes for presentation and 3 minutes for question answer.
Thank you, sir. Okay, sir. Just 1 minute. Sir, my PPT is visible.
Yeah, your PPT is visible and you are audible too. You can start.
Hello, sir.
आप unmute कीजिए. Your PPT
Hello,
is
sir.
visible and you are audible too. You can start your presentation.
Good afternoon, sir. Thank you for giving me a chance. My project name is Design and Implemented of Fault Tolerant VLSI System for Space Application on Strategy Testing and Validation. My name is Manisha Kumari. I am from TIT College of Bhopal. My presenting outline is introduction and background, problem statement, objective literature review, proposed methodology, result and discussion, and references. Very large scale integration technology forms backbone of modern space including satellite spacecraft and planetary swarm. This system rely heavily on digital electronics for communication, navigation, control, and data processing. In fault tolerant in VLSI system has become a critical requirement for reliable space mission. VLSI system are widely used in space mission. Harsh space environment cause fault reliability is critical. My keyword is fault tolerant VLSI, space electronics TMR, ECC, error correction code, VLSI design for space application, FPGA based emulation, fault injection and testing. Problem statements. Convention VLSI design are optimized for performance, power efficiency and cost in treasurable environment. When deployed in space, these are highly vulnerable to induce fault in environment states. Radiation hardened solutions are expensive and may not scale well. Advanced technology node. This is needed to cost efficient, scalable and design level fault tolerant architecture that ensure high reliability with minimized area, power and performance overloaded.
Manisha.
Objective. The main
Hello.
objective.
Manisha.
Yes, sir.
Kindly
Yes,
directly
sir.
move to your methodology and conclusion part.
Yes, sir. Methodology. Electronic systems operating in space are exposed to harsh environment conditions that directly affected reliability. High energy particles from cosmic rays and solar events are interact with a semiconductor, causing transient or permanent temperature fluctuation can lead to timing variation and material stress, while vacuum condition eliminate conventional cooling mechanism. The challenges necessitate robust fault tolerant design methodology at the architecture and system level. Needed for fault tolerance. Fault tolerance refer to able of system to continue correct operation in the presence of fault. In a space application, fault tolerance is mandatory due to long mission duration, inaccessibility for repair and mission critical function. Failure in onboard electronics can lead to loss of communication, navigation error or complete mission failure. Design level fault tolerance complete radiation hardened fabrication by providing flexibility, cost efficient and scalable reliability solution that can be implemented using standard VLSI flow. Memory protection using ECC, error correction code. Memory elements are particularly vulnerable to SEC, single error on bits. To ensure data integrity, the proposed system employs single error correction and double error deduction handling code. The error correction, this scheme correct single bit error and detect double bit error with minimal hardware overload. Periodic memory scrubbing is used to prevent error accumulation, significantly improving long-term reliability in radiation-prone environment. Fault detection and monitoring. The fault detection unit continuously monitoring system behavior by observing ACC, error flags, TMR, voter disagreement, and timing violation indication. Detect fault are classified and forwarded to fault management controller. Early detection enable rapid recovery, minimize performance degradation, and preventing fault propagation to the other component. Fault module. Accurate fault modeling is essential for designing and validation fault tolerant system. Faults in space application can be classified as a transient, intermediate, or permanent. Transient fault such as SEU and SET can cause by particle strike and do not permanently damage hardware. Intermittent fault occur sporadically due to environmental stress or marginal timing. Permanent fault such as stuck it or bridging fault result from aging and radiation damage. This module guide testing and mitigation strategy. Built-in self-test. Built-in self-test enable autonomous testing of system component without external equipment. The WIST module include a test pattern generator, output response analyzer, and controlling logic. WIST is activated during startup or idle period to detect latent fault, improving system dependability and reducing maintenance complexity. Triple module redundancy (TMR). Triple module redundancy involves replacing critical fundamental units 3 times and using a majority voter to determine the correct output. If one module fails, the remaining 2 modules vote the faulty module, effectively making the error.
Manisha,
TMR provide high reliability.
hello. Kindly wrap
Yes,
up.
sir.
Kindly wrap up quickly.
Okay, sir. TMR provide the high reliability against both transient and permanent fault and has been proven in numerous space missions. However, it introduces area and power overhead which must be carefully managed. Simulation and verification. Functional verification and fault injection simulation are performed using SDL simulation tools. Faults such as the SU and SET stuck at a intermittent fault are systematically injected, evaluation faulty coverage, detection latency, and recovery successfully. Simulation result diagnosis high reliability and validate the effectiveness of proposed fault tolerance strategy. Performance matrix. System performance is evaluated using metrics such as a fault coverage that is 90% and detection latency,
पानी से तो दीजिएगा नीचे हाँ
recovery success rate 90%, system availability 98%, resource overhead. Next, result and discussion. The integration of TMR, ACC, WIST, and fault management over provide comprehensive fault coverage compared to individual technique. The combined approach achieve higher reliability at the cost of increased area and power. This trade-off is justified for space grade system where reliability is paramount. The proposed system achieves fault coverage between 90 and 100% for various fault types. Error detection latency remain within a few clock cycle and recovery success rate exceed 90%. System availability is consistently above 98%, demonstrate sustainability for mission critical space application. The primary limitation of a proposed system include increased hardware overhead due to redundancy and higher power consumption. Additionally, only selected fault types were evaluated. Rare radiation effects such as a single event latch-up were not experimentally tested. These limitations proven opportunity for a future scope. Next. FPGA resource utilization for the faulty tolerant system. This work represents the robust fault-tolerant VLSI architecture for space application. By integrating redundancy, error correction, and self-test mechanism, the system achieves high fault coverage, low detection latency, and high availability. Simulation and hardware validation confirm the effectiveness and feasibility of the proposed design for mission-critical space system. These are references. Thank you, sir.
Okay, thank you, Manisha. Sir, if any question.
Okay, sir, thank you.
Okay. Thank
May
you,
I leave,
Manisha.
sir?
You may sign off now.
Okay, sir.
यही लिंक है ना लास्ट में 97 दूसरा लिंक तो नहीं है उसमें खास करके कहीं तो नहीं बैठा
यही है 97
हाँ यही लिंक है 97 लास्ट में जो है जुड़ा हुआ है तुम दिख रहा है क्या यहाँ का सब्जेक्ट हाँ दिख तो रहा है सब जुड़ा हुआ है
पार्टिसिपेंट में चेक करो हाँ सर ओनली वन
हाँ धनंजय साहू है
Unmute karo. Okay, so we have the last participant here for this session. Paper ID is AMN 011. You may share your slide and continue with your presentation.
Good afternoon to everyone. Am I audible?
Yes, and presentation is also visible.
Yeah, thank you. I am Dhananjay Sahu, presenting this paper on the optimization of materials recipes for the synthesis of self-filling polyurethane elastomer, that is for sensor applications. This paper is from a research project sponsored by DRDO, and it is conducted on NIT Raipur, Department of Mechanical Engineering. So next is we are in interest of developing a self-filling material that can be used to for the fabrication of various kind of flexible sensors, including strain and pressure sensors. In this particular thing, we had applied, we worked on the different elastomer that can be held at a room temperature. Next, we proceed to the material that can be held at an elevated temperature. because temperature help in regenerating or the reconstruction of bond that breaks during the damages happens in the material. The damages can be retrieved or recovered. The mechanical properties for flexible sensor, if we say the requirement is of low elastic modulus, that is we can have a small uh, for a small load we can have larger deformation, that is the high stretchability also. Then excellent elastic recovery is required because the sensors have to perform multiple times and multiple tasks, various loading and various environmental conditions. So next is about the highest sensitivity, as I told that for the minimal load, maximum strain can be generated. So we can find the changes in the its electrical properties. Ultimately, the sensing performance relate to the electrical properties like capacitance, change in resistance, and similarly other voltage, current like that. So the problem we faced in this phase of preparing a self-filling material is regarding the formulation. Which formulation should we apply, which cost is minimal, and that should be economical by process and its material cost. So we identified different polyurethane elastomer that can be that self-fill by various bond dynamics, means hydrogen bond and oxygen. So in this case, we had identified different literature where different formulation or say recipes had been shown for preparing a polyurethane elastomer, and that particularly for the sensor applications. So all are claiming that they are best, and obviously, so at a particular testing condition, their results are showing best condition, and this results in our a challenge to us for selecting a best material combination so that that can be used for the flexible sensors. This led to the multi-parameter selection challenge, and for this we had applied. So we had applied multi-criteria decision-making techniques, and therefore, particularly regarding material, if I talk, we had considered material data, oxymine-based dynamic chemistries that involve the oxymine-based chemistries for the self-filling things. Uh, this shows the low modulus and high deformable networks that is highly required for the strain and pressure sensings. And then thermally activated bond challenges, including that healing conditions under various conditions of temperature without any external healing agent that are previously used or traditionally used in the capsulation materials, capsulation self-healing things. So here will be the dynamics bond that can means accelerate their thing under the temperature condition. So this is the criteria for our material selection, and regarding the method for that, concluding our result based on that multi-criteria challenge. So recurrent Topsys method has been selected as a well-established method and extensively used and recognized for the various technologies. So the two methods have been used for selection of the best material formulation or say recipe. Next, these are the about 12 material we had selected. These are from different literature. I will show in the end. So we had considered the attributes we had considered is first of all the stress, which is minimum. We have said that minimal load and maximum deformation. So these are selected. It was arranged based on their is maximum stress. So it is from 0.25 megapascal to 36.2 megapascal. Sorry, and then the strain. Sorry, it was it should be strain. Second column it is mistakenly. So strain condition is there. Strain is not concluded based on means higher or lower. Then the stress after healing means after they had conducted various tests for mechanical testing. Basically, they had teared the material or provided a scratch thing. So after healing at a particular temperature, various temperature ranging from the 40 degree to 120 degrees Celsius. So after healing, what with the maximum stress the material can achieve, and based on their healing efficiencies, that is will be in the percent strain and stress healing percentage. So here is the graph before healing means of a pristine sample. So the criteria we had selection for analyzing means analyzing that our product will be performing this much thing is the regarding stress. It was discussed as a minimum stress and maximum strain is required for strain and healing pressure sensing. So stress after healing also it will be the lower with the better. Secondly, strain after healing it will be higher. Then efficiencies will be higher for all. So these are the performance defining attributes. Based on this, we had conducted Topsis and Ricketts test, and this is the common normalized matrix because they are sharing common formulation. Ultimately, after so much equations, we come to the results that is showing there is a comparative of the rank we received from the various material. The first rank is given to the second material, which was that STP50 zinc at 35 Li. Secondly, it was the different material we had got different ranking. For some wicker are showing changes in the sample 9, 10, 11, and 12. But 1 to 8, they are showing a common rank to the materials we had selected for them. So ultimately it come to the conclusion that this particular material it is presented here in the 2024. It was for sensor application arrays. So this material is finalized to synthesize in our lab, and again the next step is the for regarding their performance because we will make a self-filling nano composite using different fillers like carbon nanotubes and graphene that are required for pressure sensors and strain sensor application. Our next time will be the optimizing the composition, means the constituent ratio of the composite. So that can be used for the sensor application or fabrication of the sensor in our case. This is the material. The material was published in this particular paper. So it was a paper from 2024 in the European Polymer Journal, and it was telling that that mechanical properties will be adjusted or say tailored for the flexible sensors. So they are shown for the pressure sensor and strain sensors too. These are the references that 8 papers and 12 samples I have selected. And that's all. Thank you. Any questions? If
anyone have any questions?
Anyone have any questions? You can ask him, please. Okay. Thank you so much, sir. You can sign up now. So we have completed our sessions, and for now, the next session is our valedictory session, which will be resumed shortly. We have a 5 minutes or 10 minutes delay. So kindly please wait till now. Thank you so much. आप लोग अपने सीट पर ही डिसिप्लिन में रहिएगा। थैंक यू।
तो सारा सेशन क्लोज हो गया जल्दी क्लोज हो गया। 21 नंबर कौन बोला? नंबर 21 अभी क्लोज नहीं हुआ, अभी जस्ट हम सेशन एंड का हम वो किया अनाउंसमेंट, वहां पे कोई होगा तो देख कर सिलेक्ट कर देगा। उन लोगों को मुझे लीव करने के लिए एक चलता रहेगा, खत्म हो गया ये वाला चल रहा होगा राइट, ये रहेगा नहीं खत्म ही हो गया। हिंदी सभी को इंग्लिश भी हो गया नहीं लाइव निकालना देखो तो पार्टिसिपेंट पूरे में है एक पूरा ना ओके
We have one participant currently with us. Paper ID is AMN020. Am I audible?
Yes, sir, you are audible, sir.
Sir, you can go with your presentation. You can proceed with your presentation. Share your slide and proceed with your presentation.
Sure, sir. Sure. Thank you.
You have 7 minutes for presentation and 3 minutes for question answer round. So strictly follow the timeline, please.
Sure. So could you please confirm, is it visible? Hello?
Yes, sir. Yes, your slide is
I think it is
visible and
visible,
you
right?
are audible clearly. Go ahead.
Yes, sir, yes. Thank you. So for that Kennedy Silcher. So today I will be presenting this work, based energy harvesting using mass-in-mass metamaterial with piezoelectric coupling. So coming to the presentation outline. So these are the outlines I will discussing one by one. So I will begin with the background and motivation, and followed by the concept of the metamaterial based energy harvesting and the mass-in-mass material configuration. And also I will explain the simplified model, governing equations, and numerical solution strategy. And then I can discuss again regarding the experimental setup, methodology, results, and finally I will conclude my work. Now coming to the introduction. So these vibration-based energy harvesters, or VEH, have emerged as a promising solution for powering different sensors, like these self-power wireless sensors network, and also structural health monitoring systems. And among them, these kind of harvesters, these piezoelectric energy harvesters, these are kind of compact size and can be integrated with the host structure easily. As you can see in the figure, this could be integrated with human essential wiring that can be used for generating some output from human body motions or vibrations. And then actually, there are some limitations for the conventional PA without the electric patches to understand the pure mechanical behavior of the structure. And after understanding the structure, we have went for the electromechanical tests, like we have performed attaching the piezo pads to different load resistance from this 0 ohm to 10 kilo ohm. And then we have used this hand window to actually reduce the spectral leakage. Next, actually, I will discuss the experimental and numerical results. As we can see, and these are output results. So this 60 microwatt, actually, we have obtained from the numerical results at 140 kilo ohm, and so experimentally at 10 kilo ohm, we are actually able to find this 8.56 kilowatt inspired piezoelectric energy harvesters. And key achievement, we have achieved like uh, multiple localized resonance modes and effective low frequency harvesting, and also strong agreement between the numerical and experimental results, and also peak output from the numerical results 60 microwatt under the optimal conditions, and 8.56 microwatt from the experimental. And the significance could be this system could be suitable for self-power sensing applications, and future work actually could can be extend to multiple piezo-based integration, also resonance spin, and miniaturization of the aerospace for the aerospace and civil system, civil engineering system. And these are the references I have used here. And thank you. If there is any question, I will like to answer.
I think there is no question from audience side. You may sign off now. Thank you very much for your presentation and input to the conference.
Thank you. Thank you very much.
Sir, I am 013, AMN 013.
Yes, you may share your presentation and proceed. But make
Okay,
it
sir.
very brief. We are running short of time. We have to go. Kindly complete it in 5 minutes.
ओके सर।
मैं इसको लिख के भेज दूंगी।
हेलो, स्क्रीन शेयर।
Yes, your screen is visible and on. If possible, kindly share quickly and resume your presentation. दूसरे पार्टिसिपेंट जुड़े हुए हैं एक और। I guess there is some technical issue with AMN 013. I think there is some technical issue with AMN 013. If AMN 015 track ID is available with us, kindly confirm. AMN 015 if you are available. हेलो, आपको भेजा है लिंक, आप ज्वाइन कीजिए जल्दी। आपको लिंक भेजा है, जल्दी ज्वाइन कीजिए।
Nobody is responding. So participants join, but nobody is responding.
वो कहाँ लिंक कहाँ मिलेगी?
You are in the meeting, I guess.
Oh, sir,
Go ahead.
I am audible.
You are audible, but your screen is not visible. You share and start your presentation quickly.
Okay, okay, sir. Wait. Okay, so these are the
Unmute karo. Pavanji, I think there is a technical issue from your end. We are wrapping up here and proceeding for the valedictory ceremony. So you may log off from there now. You may remain in the meeting as a listener, but kindly log off as presenter. Technical issue. So, as we are about to
research insights and visionary thoughts, because definitely people, they are working from several years, and in a 1 hour just they have shared from scratch to the pioneer in the country, not only in the country, to the world. Itself is a big thing. Their deliberations have not only broadened our academic horizons, but also inspired young researchers and students to pursue innovation-driven research. My heartfelt congratulations go to all authors and presenters for their high-quality research work. Your dedications and scholarly efforts are the backbone of this particular conference. I also acknowledge the active participants of the delegates. I would like to express my sincere gratitude to the organizing committee, advisory committee, reviewers, session chairs, and volunteers whose tireless efforts, meticulous planning, and commitment ensure the smooth and successful conduction of this particular conference. A special thanks are also to the sponsors for their contribution. Thank you all.
Thank you very much, Sahu sir, for your valuable words and leadership throughout the conference. Now I would like to invite Professor Kalyan Singh sir to express your insightful thoughts over this conference.
Good evening. So now it's time for valedictory, and we are here for this international conference in one government polytechnic college. ये अपने आप में बहुत बड़ी बात है ना? So I should congratulate your honorable principal to give this environment here, so you are organizing an international conference. So this leadership is showing. Yeah, I was thinking what is going to happen when Sambhu Kumar have contacted me for this. Then very few years back, I came in this campus with meet Professor Patra in IIT Patna. Then I asked him the same place, then he told yes. Then I think I must visit and see. And really, sir, I am happy here to see the facility here, what you have given, and the freedom you have given your faculty members. They are organizing it. It's showing the very close bond between the administration and the faculty. So you are really, आप congratulations के पात्र हैं once again. So now coming to this conference, they have used in the very good way for this offline mode, online mode. A good number of papers, the different field also they have included here, and people came there and given the thoughts. Now a time is to do the postmortem of this conference. What you are getting, what you are losing. You have wasted your lot of time, lot of effort, lot of energy for this. What you are getting for this. So now for the faculty members and then for the students. I met some of the young faculty members just a few minutes before, and I told him, don't waste your time to talk about institute, to talk about principal, to talk about politics. Please do the softwares. One day it will come, people will call you through your work, not by the institute name. Okay? Once you work hard, people want to meet you. They will not search the government polytechnic and your name from Department of Mechanical and Computer and Civil. They will show your work and then they will tell you, yes, this people is working in this area, he is a faculty member is here. Especially the faculty member, we are not working for anybody. We are teaching in class, we enhance our knowledge. We are doing the research, we enhance our knowledge. We are writing a book, we are getting the royalty. We are bringing the money, the most important, thus I can say usually vitamin M. It is very necessary for the labs. And honestly, if you bring this vitamin M, your lab will become rich. Till so far you are not making your lab. You please nearby IIT, NIT, you make a collaboration. Weekly once go there and see what is happening, especially if you have holidays in Saturday or sometimes. Doing some joint collaboration nearby your institute, maybe one people will tell you, no, I don't have time. The other people will give you the time. So the young faculty members, they please don't compare with you with the old faculty members. In that time, they don't have the facility, don't have the environment. The situation of the Bihar for the 10 years back, you may not know if you are not from the Bihar. But if you see my age, those crosses the 50, we know that. So you think for the future, and you are the base for this state, and one day you feel proud. I am working on this government polytechnic as a faculty member, and government polytechnic should know due to my name. So that is my wish. Now come to the students. You are very lucky, you are studying here in this institute, and by looking your facility, I can say, your polytechnic college is better than some of the engineering college in Bihar. So you are very lucky, you are study here. One thing, if you can do the advice myself what I am talking in the many public platform meetings, please use the mobiles. Don't forget your mobiles because mobile is very close. Okay? You may not talking with your mom full day, but you cannot stay without your mobile in full day. Please use your mobile. But at the same time, please just listen my next sentence. Please careful Mobile should not use you. Careful from the mobiles. If mobile is using you, you were nowhere. Mobile will use you and throw you. Please put the mobile time very limited. Your screen time should be limited. Nowadays, we cannot say, please don't use the mobile. But mobile should not use you. Nowadays, mobile is using the student. Late night, they are putting on mobile, and next day, full day, they are not working. So you please first control the mobiles. Second, see the facility in the institute, and along with your teachers, do some of the latest course so you can employ. एक कहावत है, जो दिखता है वही बिकता है. आपको अपने आप को बेचने के लिए आपको दिखना पड़ेगा, है ना? अगर आपको अच्छा पैकेज चाहिए, अगर आपको अच्छा पैकेज चाहिए, अच्छी नौकरी चाहिए, है ना, और अच्छा पैकेज मिलेगा, अच्छी नौकरी मिलेगी, तभी अच्छा शादी भी होगा, नहीं तो शादी भी नहीं होगा, है ना? ये वैलिडिटी है. आपको ये लेसन लेना पड़ेगा कि मेरे पढ़ाई और मेरे जॉब के बाद मेरा आगे का भविष्य निर्भर है, और आपको अब उसके लिए करना क्या पड़ेगा? आपको दिखना पड़ेगा. तो आप कैसे दिखेंगे? आपको दिखाने के लिए तो कोई जगह चाहिए ना. आपके आसपास आईआईटी है, आपके आसपास एनआईटी है. आप अपने टीचर के साथ मिलकर मॉडल बनाइए और वहाँ जाके प्रेजेंटेशन दीजिए. कोई भी छोटा से छोटा चीज हो, देखिए आपका एंट्री वहाँ बैन नहीं है, आपको एंट्री अलाउ है. आप उस मॉडल को ले जाके आईआईटी में, एनआईटी में दिखाइए, जहाँ आपको मौका मिले वहाँ दिखाइए. लोग आपको जरूर अप्रिशिएट करेगा अगर एक काम अच्छा होगा तो अदर देन क्लासरूम टीचिंग एंड लर्निंग, please try to do some small project with your teachers. Just to think those who have developed the stapler. Stapler कितना यूजफुल का चीज़ है. आप अंदाज कीजिए किसी ने स्टेपलर डेवलप किया हो. आज हम अपने प्रेजेंटेशन में आपको 2-4 प्रोडक्ट का नाम बताएं जो हम लोग डेवलप किए हैं, पेटेंट कर रहे हैं और कर रहे हैं. आप सोचिए जब हम आपके एज के थे तो हम ये सोचते भी नहीं थे. आप कर सकते हैं, आप में किसी चीज की कोई कमी नहीं है, है ना? आप कर सकते हैं. आपको बस अपने आप को बिकने के लिए दिखना पड़ेगा. आप मॉडल बनाइए, उस मॉडल को देखिए. इलेक्ट्रॉनिक्स जमाना है. वंस यू डू समथिंग इट विल कम ऑन इंटरनेट. लोग दुनिया भर के क्या करते हैं, कुछ ना कुछ इधर उधर के फोटो डाल के उसे लाइक मारते हैं. आप अपना टेक्नोलॉजी डालिए उस पर. मान लीजिए आपके एक स्टूडेंट का टेक्नोलॉजी को बहुत ज़्यादा लाइक मिल गया, मिलियंस में, आपका नाम भी फेमस हो गया, आपका टेक्नोलॉजी भी फेमस हो गया, आपका इंस्टीट्यूट भी फेमस हो गया. फिर देखिए जॉब आपके पीछे क्यों ऐसे आता है ना? ऐसे बोलने से नहीं होता, आपको काम करना पड़ेगा. एंड इफ यू वांट टू वर्क अलोंग विथ योर टीचर, थोड़ा पेशेंस रखना पड़ेगा. पेशेंस रखना पड़ेगा. टीचर का डांट से नसीब सुधरता है, उसे गुस्सा नहीं करना है. सो इट्स माय रिक्वेस्ट टू द स्टूडेंट अगेन. So please control your mobile time. You cannot leave mobile. I cannot say throw your mobile, but control the mobile time. Make some good models along with your teacher and try to do all these things. Okay? So it will good for the students also. So at last, I should say thanks to the organizing committee for inviting me for this international conference, and I can again offer to all the students, all the faculty members, it's not my lab, it's your lab. Dhanbad is not very far away. You have to maintain the institute decorum, IIT-ISM rules regulation. You are free to access my lab 24/7. Sunday, Saturday को भी मेरे लैब में ताला नहीं लगता है, अंगूठा नहीं लगता है. आप 9 बजे सुबह से रात के 12 बजे तक लैब खुली रहती है. 10 से 15 बच्चे आपको हर एक के लैब में मिलेगा. 80% फैकल्टी के लैब में, है ना? आपको हम लोग भी दिखाई पड़ जाएंगे रात 11 बजे तक. आप कभी भी, कोई सैटरडे संडे नहीं होता है. आप काम कीजिए. और हम लोग सप्ताह के, महीना के अंत में यही सोचते हैं कि इस महीने के क्या आउटपुट हुआ, एकेडमिक आउटपुट. आप अपना एकेडमिक आउटपुट का एक ग्राफ बनाइए। अगर आपको कुछ काम नहीं दिखाई पड़ता है, प्रोजेक्ट नहीं है, फंडिंग नहीं है, इन्वायरमेंट आपके अगेंस्ट है, दुनिया आपके खिलाफ बोलती है, यू मेक ए ग्रुप एंड राइट ए बुक। One day that book will, so if you go some of the book shop and then you ask the book, the shopkeeper will tell you your book to in your hand. आपको इतनी खुशी होगी जितनी करोड़ों रुपए में नहीं है। आप यूपी के किसी बुक शॉप पे जाइए, उत्तर प्रदेश के किसी बुक शॉप पे, और मेरा नाम बोलिए, बिना देरी किए आपको मेरी किताब दे देगा, है ना। और मैं उसका एडवर्टाइज नहीं करता हूँ, जो भी मेरे फ्रेंड्स उसको मांगते हैं मुझे, मैं सॉफ्ट कॉपी दे देता हूँ। आई डोंट वांट टू सेल एंड मेक मनी फ्रॉम माई बुक्स। एक और बुक्स अभी स्प्रिंजर से है, आप अमेजोन पे देखिए, आपको दिखाई पड़ेगा, है ना। वो अमेजोन से इंटरनेशनल लेवल का इम्पैक्ट पे बुक है। ये कोरोना का पॉजिटिव इम्पैक्ट। इन द कोरोना टाइम आई वाज द डीन एडमिनिस्ट्रेशन अलॉन्ग विद द डायरेक्टर ऑफिस एंड वी हैव वर्कड वेरी हार्ड and saved the life of 270 people day and night. But we feel that tomorrow is the last date for me also. That was the situation in Corona. And when coming back, my room is separate from in my house, and my meals was coming in that room. I start writing this book. And the Corona ends, everybody is safe in my campus, and I publish a book in Springer. Now this book is live. The cost of this book is 12,500. Please don't purchase it. Don't give the money to the publisher. If you feel some chapter is good, you send me a WhatsApp, send me the mail. I will send you free of cost. You don't have to purchase. So it's my opinion. Always think positive. Everybody have negative. If people don't have negative, everybody become the God. Everybody have the negative. But from that negative, you please bring out the positive. After 5 years, आप बैठे हुए सोने के लिए जाओगे तो मिनट नहीं लगेगा, आपको नींद हो जाएगा, आपका नींद हलाल नहीं खत्म नहीं होगा। So you please think positive, do the hard work, and the success will back and call you. Thank you, thank you, thank you.
Thank you, Kalyan sir. We feel privileged to have you in this conference. और आज हम सभी को उनसे बहुत कुछ सीखने को मिला है. Now I would like to invite our respected patron, Dr. Chandrasekhar Singh sir, to kindly address this.
Good evening, everybody. Dr. Kalyan Singh Saab from ISM Dhanbad, Dr. Piyush from Texas, Dr. Sahu from NIT, our senior faculty members, the participants who are participating offline and online in this international conference. I welcome you all in this valedictory function. I am very much thankful that you people have supported us to convene this conference, that international conference, which we dreamed 2-3 years back. And as Dr. Piyush and Dr. Kalyan Saab and all the speakers has mentioned, so really the organizing such an international conference in Polytechnic was beyond the thinking. So we started talking with our faculty members that we have not only participated so many international conferences, but we have organized also. So you should have the energy, you should have the plan to organize such conference, you will succeed. And now I am saying this with core of my heart, that whatever I have dreamed, you people have done better than that. So I congratulate my all faculty members, my staff and my volunteer students and all students who are participating in the event, offline and online. This international conference, whatever paper has been produced and presented, unfortunately due to the administrative work I cannot sit with them entire day, but during night I have just scrolling the YouTube, live YouTube, whatever they have posted, and I got much impressed that जितने भी कॉन्फ्रेंस में मैंने भाग लिया वो सबसे अच्छा कॉन्फ्रेंस ये था, बिकॉज जो टाइम का डिमांड था हम उस टाइम के साथ मिलके ये कॉन्फ्रेंस किए थे, और वो था इमर्जिंग टेक्नोलॉजी, और वो डिमांड था। ईयर 2025 में गवर्नमेंट ऑफ बिहार ने एक कल्पना की, ट्रांसफॉर्मेशन ऑफ बिहार leveraging the technology, and yes, we have started our step in that direction, and I am very thankful to our faculty members and the participants who presented the paper, and our listeners who got benefited with these papers, that जो भी टेक्नोलॉजी का ट्रांसफॉर्मेशन उन्होंने सोचा उस दिशा में हमने काम किया, और ये सबसे रिलेवेंट है। आज के डेट में हम कॉन्फ्रेंस कर सकते हैं कि हमारे नालंदा के रूइंस में क्या क्या तकलीफें थी, किसने आग लगाया, किसने ईंट हटाया, लेकिन ये रिलेवेंसी जो बिहार को आगे ले जाएगा, जो इंडिया को आगे ले जाएगा, जो विकसित भारत बनाएगा, उस पर हम काम कर रहे हैं, और वो पॉलिटेक्निक लेवल में काम कर रहे हैं। इस बात को कहते हुए हमें गर्व हो रहा है। और ये अप्रिशिएशन, सर, आई एम एश्योरिंग यू, वट एवर कल्याण साहब हैज टोल्ड अस, टू आवर फैकल्टी मेंबर्स, टू आवर स्टूडेंट्स, टू आवर रिसर्चर, आप अपने दिशा में काम कर रहे हैं। आपका क्लास लेना, प्रैक्टिकल कराना, बच्चों को पढ़ाना, अपने लर्निंग करना अपनी जगह है, लेकिन आप जिस रिसर्च एरिया में काम किए हैं, आपने जो पीएचडी किया है, आप जो एमटेक किया है, पॉलिटेक्निक में वो सुविधा एमटेक कराने की नहीं है, वो सुविधा पीएचडी कराने का नहीं है, बट आप अपने रिसर्च को कंटिन्यू कर सकते हैं थ्रू योर स्टूडेंट्स। देयर इज नो बाउंडेशन, देयर इज नो बाउंड्री, देयर इज नो लिमिट, आई एम टेलिंग यू कैन गो बियॉन्ड, बिकॉज you are not only working in a polytechnic, the new government polytechnic have, अब तक जब आप जान रहे हैं जैसा एसोसिएशन हम लोगों का है, whatever research paper you want to do, whatever research जो भी फील्ड में आप करना चाहें, you can associate with the IIT Patna, and I'm assuring you that जिन फैकल्टी से आपको काम है, जिन लैब से काम है, वो लैब आपको उपलब्ध होगी। और जैसा कल्याण साहब बोले, आईआईटी धनबाद में जब उपलब्ध है, एवरीथिंग इज अवेलेबल नाउअडेज इन ऑनलाइन आल्सो, सो देयर इज नो नीड टू गो फिजिकली एंड डू द वर्क। जैसे आपने पारंगता हासिल की है वर्चुअल लैब में, उसी तरह जितने लेबोरेटरी है, हमारे स्टूडेंट्स भी पारंगत है उन सबको यूज करने का, तो आप फैकल्टी मेंबर तो है ही। अपने रिसर्च को आप आगे बढ़ाएं, और ये न सिर्फ आपके लिए, बल्कि जैसे ही आप आगे बढ़ेंगे तो ये नाम होगा इस इंस्टीट्यूट का, ये स्टेट का, ये पूरे देश का, और आप अपने आप को, जो भी आपने सपना सजाया है, वो सपना आपका पूरा होगा। सर का कहना सही है कि हम अगर 50 मेंबर फैकल्टी मेंबर आज सोच रहे हैं कि सब आदमी हम डीन बन जाए, सब आदमी हम एचओडी बन जाए, वो संभव नहीं है, लेकिन रिसर्च के फील्ड में सब आदमी अगर चाहता है कि हम आइंस्टीन बन जाए तो वो संभव है, और उसके लिए आपको सुविधा उपलब्ध है। आप ये मत सोचिए कि हम पॉलिटेक्निक में काम कर रहे हैं, आप आईआईटी पटना के एसोसिएशन में काम कर रहे हैं, आप एनआईटी पटना के एसोसिएशन में काम कर रहे हैं, आप आईआईटी धनबाद के एसोसिएशन में काम कर रहे हैं, और ये बॉन्डिंग आपको इंटरनेशनल कॉन्फ्रेंस के साथ साथ अन्य जो हम लोग कोलैबोरेशन किए हैं उन सब से आपको एबिलिटी मिली हुई है। तो आप हौसला को इसी तरह बनाए रखें। जो एनर्जी, जो इंथुसियाज्म और जो जील आपने इस इंटरनेशनल कॉन्फ्रेंस के सफल होने में आपने किया, वही आपको आगे भी करना है। और हम उम्मीद रखते हैं ना केवल अपने फैकल्टी मेंबर से, कि अपने जो लास्ट बेंच के हमारे स्टूडेंट्स हैं उनसे, जो आपके कैरियर में, आपके लाइफ लॉन्ग जिंदगी में बियॉन्ड सिलेबस ये चीजें आपको याद रखेंगे कि हमारे पॉलिटेक्निक में इंटरनेशनल कॉन्फ्रेंस हुआ था और वहाँ कल्याण साहब आए थे, वहाँ पीयूष साहब आए थे, वहाँ साहू साहब आए थे। और आप भी अपने कैरियर में जरूर ऐसा काम करें जो आपके ऑर्गेनाइजेशन में, आपके फैमिली में वो ऐसा संभव नहीं दिखता है, लेकिन आप ड्रीम करें, पहले सोचें और उस काम को संपादित करें। और वो स्थापित करेगा अपने आप को कि आपकी पर्सनालिटी है कि आप कर सकते हैं, आप में वो लीडरशिप है कि आप वो कर सकते हैं। हमारे जो भी पार्टिसिपेंट्स हैं इस इंटरनेशनल कॉन्फ्रेंस में और जो उन्होंने पेपर प्रोड्यूस किया, जो प्रेजेंटेशन दिया, उन सबको मैं एक बार धन्यवाद देता हूं। हमारे जो विषय विशेषज्ञ और हमारी महान हस्तियां जो आज डैश पर हैं, मैं उन सबको पुनः एक बार धन्यवाद देता हूं। और उनके साथ साथ आप सभी ने जो इतने मेहनत कर रहे हैं पिछले 6 महीने से लगातार, मैं देख रहा हूं 24/7 पीपुल्स आर वर्किंग ओवर इट। और इसके लिए हम लोगों को किसी से कोई फंड नहीं लेना पड़ा है, किसी के तरफ कुछ देखना नहीं पड़ा है, और हम लोगों ने इसको संपादित किया है अच्छे तरीके से। ये सब के लिए आप सभी फैकल्टी मेंबर्स को, सभी पार्टिसिपेंट को कोटिशः धन्यवाद।
Thank you so much, sir, for your inspiring and motivating message. Now we move towards one of the most awaited segments of this valedictory section, that is appreciation. So now I request all the dignitaries to kindly present the certificates to the organizing chair, organizing secretaries, and to the local organizing committee members. So please. In the organizing chair, we have first Professor Karali Patra sir, who is not available right now, but he has taken a very much good effort for conducting this conference. The next one is Dr. R.K. Sahu sir, Associate Professor, NIT Raipur. Next, Dr. Sambhu Kumar sir from New Government Polytechnic, Patna 13. To the organizing secretaries, Dr. Ashutosh Kumar sir. Next, Mr. Rohit Kumar sir. Next, myself, Dr. Anushka Pradhan.
Next we have Dayasankar sir, our Dean Academics.
Mrs. Roma Rani ma'am, HOD Electronics and Communication Engineering. Next, Tribhuvan Kumar sir. Next, we have Pratyay Amrit sir. Mr. Syed Aftab Ahmed sir. Mrs. Aisa Alam. Dr. Shaktinath Singh, HOD, Computer Science Engineering. Next, Mr. Mahesh Kumar sir. Next, Mr. Nishant Kumar sir, HOD, Mechanical Engineering. Mr. Umar Farooq sir. Mr. Tribhuvan Kumar sir. Mr. Amit Narayan Mishra sir. And last, Mr. Ramendra Rahul sir. We will send all the presenter as well as the attendee certificates through the email. We also express sincere appreciation to the Technical Reviewing Committee. To the Technical Reviewing Committee for their valuable time, effort and expert evaluation. Now for the formal vote of thanks, I would like to invite Dr. Ashutosh Kumar sir to kindly deliver a vote of thanks.
I am happy to announce you one very important information. We are, Sambhu Kumar have asked me many times, sir, we want to publish some paper in the Sadhana. So 2 days back, I became the associate editor for this journal. So send some quality paper without compromising with the quality of this. We'll publish some paper, and this is a Q2 journals. Thank you very much.
Thank you so much, sir. At the last of this 2 days event of International Conference on Advanced Engineering and Emerging Technologies, it's time to say thanks to our patron, local organizing committee, and all the other valuable input to this conference for making it a success. I would like to start from the RK Sahu sir. Sir, जिस दिन से ये incubate हुआ idea for ICATEET-2026, RK Sahu sir has been continuously, effortlessly giving us the ideas how to conduct the international conference, how you can collaborate with the publishers, how you can collaborate with the sponsor or other valuable assets to the conference. Sir has been the idea behind this conference along with Professor Sambhu and Karali Patra sir. These three persons have been continuously, effortlessly, and tirelessly giving the input to the making it success. I would like to thank Dr. Karali Patra sir in absentia. He is not here, but he has been the motivation behind this international conference, ICATEET-2026. I would like to thank Dr. Kalyan Kumar Singh sir. 2 days in the first half session, sir has told us about the lab, the kind of lab sir has developed, fully equipped world-class lab, and not for the IIT, ISM Dhanbad, but for us. So thank you so much, sir. Sir deliver a lecture where sir has started from the type of failure and mechanism of failure to the patented research inputs. So that was the dynamics of sir's today's speech, and the dynamics of sir has shown to us in this conference. I would like to thank our principal sir, who is the patron of this conference. Sir, what to say? Since last 8 years, the one thing that we have noticed, the permission to commit mistakes, as sir has allowed us to commit mistakes, that is commendable. And that permission to commit mistakes give us courage to go beyond the boundary and think which can be done without keeping in mind that whether we will fail or we will succeed. That permission to become, that permission to fail is something that allow us to push our boundaries. Thank you so much, sir. The day, जिस दिन हम लोग ये आइडिया लेके सर के पास आए कि सर हम लोग ऐसा करना चाहते हैं, विदाउट गिविंग इट सेकंड थॉट, हो सकता है सर के दिमाग में बहुत सारी चीज़ें चली होगी, होगा नहीं होगा, कर पाएंगे नहीं कर पाएंगे लोग, बट उन्होंने इस चीज़ को एक्सप्रेस नहीं किया. वेरी फर्स्ट डे सर हैज सेड ओके वी विल गो अहेड विद दिस एंड आप लोग कैरी ऑन कीजिए, आई एम देयर टू टेक केयर ऑफ एवरीथिंग, यू प्रोसीड विथ योर आइडिया. दैट काइंड ऑफ guardianship, I may say, is we all require to assure the academic excellence in the institution. Thank you so much, sir. I like to thank our in-house conference chair, Dr. Shambhu Kumar. जब भी ये कभी आते हैं पास में और बोलते हैं कि एक चीज़ सोचे हैं, तो लगता है कि पता नहीं अब कौन सा आइडिया लेके आए हैं और कहाँ तक लेके जाएंगे इसको. बट हम लोग का इतना भरोसा है सर पे कि जब भी कोई आइडिया लेके आते हैं तो पता होता है कि पीछे कोई ना कोई मैकेनिज्म सोच के लाए होंगे, और जो भी कुछ नहीं होगा दिमाग में तो हम लोग साथ में मिलकर कर लेंगे. और पिछले 7 सालों में जो हम लोग साथ में मिलकर कर रहे हैं, तो आज तक तो मीन्स ऐसा मेजर फेल्योर नहीं आया है. हम लोगों ने जैसे तैसे उसको अच्छे से कर लिया है. थैंक यू शंभू सर फॉर ऑल द टाइम कमिंग विथ सम न्यू आइडिया. आई वुड लाइक टू थैंक डॉक्टर अनुष्का प्रधान, ऑर्गेनाइजिंग सेक्रेटरी ऑफ दिस कॉन्फ्रेंस. शी हैज बीन कंटिन्यूअसली विदाउट एनी टाइम बाउंडेशन. हम लोग कभी कभी सोचते हैं कि आई मीन फीमेल स्टाफ टाइम का बाउंडेशन होगा, बट विदाउट एनी बाउंडेशन रात के 1 बजे 2 बजे मैसेज करो, रिप्लाई मिलेगा रिगार्डिंग आवर एनी आइडिया which you are going through. Thank you ma'am, thank you for your I mean continuous support. I would like to thank Mr. Rohit Kumar, our organizing secretary. थकते नहीं हैं और रुकते नहीं हैं. जील टू लर्न. जब भी कुछ नया चीज आता है तो पहले किया हो नहीं किया हो, पहले ऐसे चीजों में इन्वॉल्व हुए हो नहीं हुए हो, ऑलवेज ही हैज अ जील टू लर्न एंड एबिलिटी टू परफॉर्म. थैंक यू सर फॉर बीइंग विद अस. आई वुड लाइक टू thank our collaborator Xavier University, who has been accepted our invitation to collaborate with us, and I'm sure we both the parties have been benefited from this idea of ICATEET-2026. I would like to thank our sponsor, media personals. A special thank to local organizing committee. Our vice principal sir is here, Dr. R.N. Singh. Sir is a big motivation, a big motivation. जिस टाइम में लोग अब आराम करने का सोचते हैं, सर अभी भी हम लोगों को कंटिन्यूसली मोटिवेट करते रहते हैं कि आप अपना नाम खुद से बनाइए. थैंक यू सर, थैंक यू फॉर सच गाइडेंस टू अस. आई वुड लाइक टू थैंक दयाशंकर सर, आवर डीन एकेडमिक्स. रिस्पॉन्सिबिलिटी कभी कभी हम सोचते हैं कि ये छोटी रिस्पॉन्सिबिलिटी है, ये बड़ी रिस्पॉन्सिबिलिटी है. आज तक मैंने 8 साल में कभी भी ऐसा नहीं देखा होगा कि दयाशंकर सर को जो भी काम मिला हो, चाहे वो कैसा भी हो, जहां हम लोगों को लगता है कि सबसे ज़्यादा मुश्किल आने वाली है, हम काम सर को थमा देते हैं. जहां पे ज़्यादा मैकेनिज्म यूज होगा वहां पे सर को लगा देना है. ही विल फाइंड द इजीएस्ट वे टू कंप्लीट इट. थैंक यू सर, थैंक यू सो मच. I would like to thank all the faculty members who has been contributed through the local organizing committee. Tribhuvan sir, Praveen sir, Nishant sir, Prashant sir, Mahesh sir, Roma ma'am, Aisha ma'am, Asika ma'am. Then we have Farooq sir. Then we have Pratya sir, Shaktinath Singh sir. All the technical support that you have seen in these 2 days has been given by these local organizing committee. Especially I would like to thank Pratya sir, Farooq sir and Aisha ma'am and Shakti sir. They have been continuously, tirelessly, because see, the thing is, we were running 4 meetings simultaneously, parallelly. And the infrastructure we have 2 WebEx ID. One is of higher version and one is of our institute level that we conduct the meeting on. So 4 meeting continuously in both the session, in first half, in second half, entire day we have parted it in 3 half. First half 2 sessions, second half 1 session. Today it was first half 2 sessions, second was 2 sessions, total 4 sessions today and 3 sessions yesterday. So 7 sessions parallelly. So a big thanks to you guys and thank you for making such arrangement that हम लोगों ने कहीं भी difficulty feel नहीं किया. I would like to thank all our staff members, our volunteers, student volunteers, our apprentice who has been continuously working since last 10 days to make it happen, make it completed smoothly. I would like to thank our student volunteers. ये लोग भी नहीं थकते हैं, शायद इनके फैकल्टी को देख के इनको एनर्जी मिलती होगी. पिछले 3 दिन से बिना खाना का परवाह किए, खाना टाइम पे आया नहीं आया, थोड़ा लेट हुआ, कोई बात नहीं, बट कहीं भी हम लोगों को शिकायत का मौका नहीं दिए. जहां जिनको लगाया गया था पूरी ईमानदारी के साथ अपने काम को अंजाम दिया है. थैंक यू सो मच यू गाइस, यू डिजर्व अ बिग अपलॉज. Last but not the least, I would like to thank our security staff members, our cleaner, sweeper, whosoever is associated with this conference and making it happen successfully. Thank you so much. With this, now
all of us.
National anthem ready. So at the end, we will play our national anthem and we will stand in the respect of our national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Make your move with hosting.
And this was the first international conference, ICATEET-2026. We hope that we will continue this series, second, third, fourth, and so on. Thank you, sir. So this is the official closure of this 2 days event. Thank you so much for joining us.
इसको बंद कर दो बंद करो अच्छा हम लोग ज्यादा एक ग्रुप फोटो करिए